Greetings. Welcome to the Azure AZ-900 Fundamental tutorial. I am going to be going over this tutorial with you. I'm going to follow the course outline as prescribed by Microsoft, so we cover all the bases for the examination. This is a one-star certification. I'll be going over it with you, and we are going to go through the topics the way Microsoft have it laid out. In some cases, I might switch it around, but we'll go over it in details. All right, so before I get started, let I introduce myself. My name is Everett Morris from NetMerge, and I have over 20 years experience in IT doing software development with roles with different responsibilities across different companies. Now, let's get started and start looking at the course. Let's talk about preparation up front before we go any further. Now, if you have a little bit of experience, say for example 2 years experience, it should take you approximately 8 hours to prepare for this exam, and you should be able to do well with it at that point. I'll explain what preparation is in a second. If you have little to no experience, it should take you approximately 12 hours to prepare for this exam. And if you have absolutely no IT experience, you're new to IT, you're a decision maker, and you want to get your feet wet with Azure or cloud computing, it doesn't matter. It will take you approximately 20 hours watching this video, taking some notes, and going over your notes to do really well on the exam itself. So now let's dive into the course and take a deeper look at the course itself. I'm going to be taking you through the roadmap of what you could do. As it is right now, this is a one-star fundamental course. It's not anything you could really put on your resume at the moment. It's a fundamental, but it's a good course because it's laid a foundation for you to build on for Azure, for other Azure certification programs. So let's take a quick look at the roadmap. This is a quick look at the roadmap. We're at the beginning with the fundamental course. Once you take the fundamental course, you could go to the associate level, which is a lot of two-star courses that you could take. There's approximately 6 of them, depending on what area you want to focus on. So you could take one of these courses after you take the fundamental. Now, the fundamental is not a prerequisite for any of these courses, but all the associate level courses can be a prerequisite for the expert level courses. So if you're going to take, say, for example, the solution architect expert, you'd have to take one of these prerequisites, and as you could see, it's a 2-tier exam process. You have to pass 303, then 304. For a DevOps engineer expert, you just need to take the AZ-400 and you're on your way. Now, there are 2 specialty courses, as you can see, AZ-120 and AZ-220. All right, so let's get started and move forward. Okay, so this is just the general course overview. I want to go over it really quick with you so you have an understanding of what we'll be covering. This is what Microsoft have on their website as of January 25th. So we're going to be talking about cloud concepts. I'm going to spend about 20% of the time on it. And then we're going to move on and we're going to talk about core Azure services. I just want to bear in mind the first chapter is not about Azure, it's about cloud computing in general. Chapter 2, we get into Azure all the way to chapter 6. There's a total of 6 chapters. Third, then we're going to talk about solutions and management and tools in Azure. That's 10 to 15%. It's not a long chapter. Then we go to chapter 4. We'll be describing general security and network security features. Azure is really big in security and compliance and privacy and all those things. So we'll be going over that. Next, we're going to be talking about identity, governance, privacy, and compliance features. So we'll be talking about security, password, overall governance, and compliance. Privacy, how your data is kept and maintained by Microsoft. Then we'll talk about compliance, regulatory compliances, etc. And then finally, we'll describe Azure cost management, cost of the cloud, how to assess your costs. We'll talk about that, and we'll also talk about service level agreements, 10 to 15%, and those has to do with agreement between you and Microsoft. Now, what I want to do, I want to take a quick look, go to the website, give you an idea what the course outline looks like so we could jump into it. So let's take a look. We want to type in AZ-900. And once we start typing, actually, let's type Azure AZ-900 to be exact, Azure AZ-900, and we want to look at the certification. Now you want to scroll down and you want to look for the AZ-900 exam as it is offered by Microsoft. So there it is. So what I want to do, I want to give you an idea what the course outline is. While we're going to that, I want you to know the course is $99 to sit the exam. It doesn't matter where you take it, it's $99 in the United States. If you go somewhere like, for example, in the Ukraine, there's a lot going on there, it's $55. So my take is that the cost is based on your ability to pay. Now, Microsoft, they partner with Pearson VUE. That's the company that monitors the exam, and you would have to schedule an exam with Pearson VUE. It's very easy to schedule an exam, and they have a lot of sites worldwide that you could use. Now, my purpose for this page is to go over the course outline. Now, let's take a look. This is exactly what we just went over in the high-level course overview, and what I want to take a look at is the actual course detail. This is where you could find the detail. I implore you to download the course detail, go through it at your leisure, and use it to follow along, because that's what I'll be using to go through this course. So that's a course outline. I give you an idea where you could get to the course outline, and then we are going to go back to our demonstration with the slide. So let's move on. We're going to be describing the first chapter, describing general cloud concepts. Let's get right into it. What is cloud computing? That is what we are talking about. Well, cloud computing is a delivery of computing service over the internet as a better alternative to on-premises data center. So it's delivering computer services over the internet in a nutshell. Now, computing services is what you might ask. What is computing services? This include but not limited to servers, virtual machines. We'll be talking about that, storage, database, network, and software services. So we'll be talking about that as well. Now, before we start talking about cloud computing, services are offered in 3 layers in cloud computing, and the layers are referred to as IaaS, PaaS, and SaaS. That is infrastructure as a service, platform as a service, and software as a service. Don't worry about it now. We'll get into it. We'll be talking about it so frequently it'll become easy to you by the time we get halfway through the course. Now, as it relates to market share, Microsoft has approximately 21% of the public cloud market share in 2022. The leader is AWS, Amazon Web Services. Okay, let's take a look at some cloud concept. The first thing we're going to be talking about is high availability. High availability is the ability to keep your service up and running optimally with near nil downtime. So when you hear the term high availability, just simply think about uptime. You have your service up 99.99% of the time over a given period of time. That is what high availability is about. Scalability is another feature in the cloud. It is the ability to grow seamlessly on demand when traffic, memory use, or computing power are in great demand. So it's your ability to meet a specific demand. There are 2 types of scaling. There are vertical scaling, you scale upward, and horizontal scaling, you scale in and you scale out. So vertical scaling only goes in one direction, it goes up, and horizontal scaling can go both direction, it's bidirectional. That's a big difference between the two. Now, scaling up increases existing resources to meet demand. So if you have a server and you want to upgrade the storage capacity of the server, you have 100 gigabyte, for example, you upgrade it to 200 gigabyte, then you use up 150 of the 200 gigabytes. Now you can't scale back down because you have data loss. So that's scaling up. It's single direction. Now let's look at elastic scaling. Elasticity is horizontal scaling. It's the same thing. It's Azure's ability to grow and shrink horizontally, moving in and out. It is adding more of the same resources or configuration. I'll expand on that. So what it's basically saying is if you already have a computer with that software running on it, say for example Microsoft Excel, and you want to scale with that particular computer, you'd have to create more of the same computer, additional units. So you're not upgrading, you're expanding. That's the difference, and that is elasticity. Now let's go over some example of elastic scaling in cloud computing. So one example is what is referred to in Azure, but it's also in other cloud service providers setup, is what is called a scale set. So in Azure, you're allowed to create a scale set, elastic scale set by adding virtual machine to the same configuration to meet demand, and when they're no longer needed, you could deallocate or you could get rid of those resources. So it's the ability to create a lot of virtual machine as a group of machine, but they have to have the same configuration. So that is elastic scaling. Now there's another example that is not so popular, which is called a stretch database. It's really a form of hybrid scaling, and what this involves is if you're running a data center on premises, meaning your personal private data center, and there's a lot of demand and you need to scale out, you are able to use the cloud service provider to scale out, so you're stretching your database onto the cloud. Once you're finished with your high volume work, you could scale back down and go back to your on-prem solution, and that is referred to as a stretch database. So we're moving on. I spoke about scaling. Now I'm going to look at agility. Agility is the ability to react and respond quickly to a request. So agility enables users to be able to allocate and deallocate resources very quickly. That should sound familiar. That is elastic scaling. So agility is one of the benefits of elasticity, and elasticity is one of the benefits of cloud computing. Now let's take a look at disaster recovery. It has high durability. Now what we're talking about here is fault tolerance. Disaster recovery is your ability to tolerate a fault if there's a disaster, and you're able to recover from it seamlessly without the end user services being interrupted. So the ability to recover from a disaster without any data loss or downtime is one of the hallmark of high availability. So we're still talking about high availability here. Next is global. Because the cloud service providers have a lot of data centers across the globe, then they have a global footprint, so they are global. Currently, Microsoft Azure has 60 regions in 140 different countries. They're also security. Cloud service providers take great care in providing a high level of security, both physical and technical security. Physical security would be example like your security guards and your surveillance cameras. Your technical security would be like your firewall, your password protection for your resources, and that type of stuff. So you understand security in the cloud. Now let's take a look at current. The cloud is current. You're able to do updates seamlessly without any interruption. Now when we talk about update domain and fault domain downstream, you'll understand how this is able to take place without any interruption. They are planned incidents, and they're not, they're not, even though they're planned incident, there's still preparation that went into the entire procedure to make sure that the process is seamless and it doesn't interrupt production. Okay, so let's move on. We're going to be talking now about expenditures, capital expenditure versus operational expenditure. Let's talk about that. What expenditure? Now, capital expenditure has to do with the upfront. In fact, let me just talk about this a second before. Economies of scale is part of the larger total cost of ownership assessment. So it's really the process of doing an assessment between your on-premises data center or if you're using a cloud service provider. So that entire process to rationalize the economies is referred to as the economies of scale. Now let's talk about capital expenditure. It has to do with your physical upfront costs for hosting your on-premises data center. This is usually a huge, unpredictable investment that you have to come up with upfront. That is capital expenditure. The alternative is operational expense, which is OPEX, and it has to do with the public cloud as the alternate solution, and costs are mainly associated to intangible resources that you would lease or rent from a cloud service provider. So that's the key difference between CapEx and OPEX. Now, OPEX uses what is called a consumption-based model. It is one of the most attractive incentives in cloud adaptation. You pay as you go, and it's a very fluid pricing structure. So we're going to be focusing mostly on operational expenses. I just want you to understand the difference between the two. So we're talking about cloud computing. So obviously we're going to be focusing on the cloud type of expense for this tutorial. Now let's look at some of the core benefits of the OPEX versus CAPEX. So OPEX has a cost saving incentive over CAPEX. In addition, you get on-demand scaling solutions and options that support elasticity and agility. Now you get dynamic scheduling. I'm sorry, we're doing core benefits of Azure. I'm sorry. You get dynamic scheduling of software releases and updates. So instead of doing it on a monthly basis where you have to wait on a specific window, for example, a holiday or very early in the morning when traffic is low, you could do updates in the cloud and you don't have to worry about it because it's taken care of for you by the cloud service provider. Now, it's current and global. The ability for your compute, your mobile application, your storage, your web application, and your network services, they're current, so they are always updated seamlessly, transparently to you, the end user or the tenant. And it's also global because the cloud service providers have a global footprint all over the globe. Now we're going to move on, and I'm going to be talking about another concept in cloud computing, which is referred to as shared responsibilities, also known as division of responsibilities. So the division of responsibilities model has to do with how responsibilities are divided among cloud service providers such as AWS, Amazon Web Services, and Azure, and the customers or tenants. So, tenants is a customer in a cloud service provider setup or in public clouds, native clouds. So we're going to look at the responsibilities, who is responsible for what. And remember, we talk about where the services can be served. So we talk about platform as a service, software as a service, infrastructure as a service. So we're going to be looking at that in more details. Now, the workload responsibilities vary depend on whether the workload is hosted on one, software as a service, two, platform as a service, three, infrastructure as a service, or if your workload is hosted on site, on premises, your own data center. Now let's look at a pyramid that will help us drive the point home. This is referred to as a cloud model pyramid. At the bottom of the pyramid is infrastructure as a service. At the middle, you have platform as a service, and at the top is software as a service. So let's get to understand this a little better. As you can see, your own data center is not on the pyramid because you are fully responsible for the service in your own data center. So we're talking about responsibilities. So remember that. Now let's look at the different responsibilities and services that are offered. Let's look at the services so we get an understanding of the responsibilities. So at the infrastructure of as a service, the cloud service provider is responsible for the core compute services such as a virtual machine that you would or server that you would create on within the cloud. So that's referred to as compute, and it's at that level. That's where that type of service would be offered at the infrastructure as a service level. So you get compute, you get storage, different storage type, you get your network services where you could configure your own network, and this is offered as a consumption based model, pay as you go pricing. You're leasing the time and service and the storage resources, or all the resources from the cloud service provider. Now, the next tier is referred to as a middleware framework, and this is specifically for software developers, a different type of end users. Infrastructure as a service is for administrators, system administrators. Now, this is for software developers, third-party resources that you could use to build and test application. So your database is your Cosmos DB, your SQL database, your Postgre database, your MySQL. They would all be located at this location. If you're a software developer like myself, you would bring your Visual Studio. If you're a Java developer or Python developer, you would bring your integrated development environment at this location. This is where you would install your development suite or your text editor at the platform as a service level. Now, the next one we should all be familiar with. This is a end user solution where you would log into a service or a paid subscription over the internet through your web browser. An example of software as a service, let's get rid of this P. It's supposed to be an S. My apologies, that's my mistake. Now, at this level, your Google email will be considered software as a service. All you need to worry about is your username, your password, the device you're logging on to, and the emails that you create, which would be your information or your data. Office 365, remember the Excel file that you created, it would be at this location if you're using TurboTax. These are example of workloads that would be offered at the software as a service level. Now I'm going to show you another side-by-side illustration to drive this point home. Now, as you can see, on premises, you're entirely responsible for everything on premises. That is what the customer designated dark blue box means. Now, for the Microsoft or the cloud service provider, which is Azure in this case, they would be responsible for all the bottom tier services, which would be at the infrastructure as a service level that we spoke about. So the physical data center, the physical security, the high availability, that would be their responsibility. The physical network, the cable company, the fiber optics line, those would be their responsibilities. The physical hosting, the hypervisors for you to create your virtual machine, that would be their responsibilities. Now, similarly, if you look at infrastructure as a service, you, the tenant or customer, would have a lot more responsibilities at that bottom level. As you go into the middle, your responsibilities dwindles a little. These are shared responsibilities, 50-50 responsibilities. As you go across your application, your identity and directories, those are 50-50 responsibilities. So I hope you're understanding the concept now of shared responsibilities. So as you go up the pyramid from the bottom up, the cloud service provider has more responsibilities. Now, if you go on the other side, as you go down the pyramid, you have more responsibilities as the tenant or the consumer. One thing I want you to take away, I want you to know it doesn't matter where your workload is located, on-prem, infrastructure as a service, it doesn't matter. You are always responsible for your information. So your Excel file, you open Excel, you create a spreadsheet with a macro, you're responsible for the file you created. You're responsible for the device you use to create that file, your endpoint. You're also responsible for your accounts and identities. The password and username you use to log in, they belong to you. So you're always responsible for those. And you also have some shared responsibilities when you talk about identity and directory infrastructure, also for application. So you should get a general understanding of what shared responsibilities inside a cloud service environment. Now let's look at some of the benefits at the software as a service. These are some of the benefits that you would get. You only need to bring your Excel skill set. For the shared responsibility, you don't have a lot of responsibilities. Those are some of the benefits. You don't have to worry about upgrade and maintenance. The only disadvantage that I am aware of is you don't have user level control. And I'll give you an example. If you're using Microsoft Office Suite, you might only need to use Excel, but you still have to purchase Word, PowerPoint, Publisher, and all those other software. So you don't have granular control over your software. So that is what the disadvantage is. Now let's look at the middleware and take a look at some of the benefits at the platform as a service. You get agility, you're very robust, you're able to manage both the cloud service provider is managing both your infrastructure and the platform. You don't have to worry about that platform. As a matter of fact, that platform as a service is often referred to as serverless computing. We'll talk about that later on. Now let's move on. Another benefit you get as a software developer, you don't have to worry about the servers, the computing, and the network running in the back end. You just have to worry about your skill set and your application that you need to do your work. So you're able to focus and be more productive. That's what that is talking about. Now you have exceptional off-the-shelf capabilities as well. A lot of support are there for you in the Azure Marketplace. I will talk about the Azure Marketplace. It's a third-party marketplace that you could go and purchase tools that could complement solutions that you're working on in Azure. So those are the benefits at the platform as a service level. Let's look at some of the, before we do that, let's look at the disadvantage. The biggest disadvantage is you also have less control over your infrastructure. So things and tools that you test with and the middle tier level at a platform as a service level, when you deploy your application in production, you might not have those granular control over your application anymore. So that again is a single disadvantage that I'm able to identify at this level. Now, if your workload is on the infrastructure as a service, it's the most dynamic category. You get a lot of control because you're a system administrator. You're able to create your own virtual machine, set your own password, create your own virtual network and subnetwork. So you have a lot of control. You get agility as well. You get shared responsibility. You only focus on the services that you provision. You don't have to worry about maintaining the data center. The backend risk is offloaded to the cloud service provider. You get endless talent base by capitalizing on the resource pool or the human resource pool and skill set that the cloud service provider have in-house. You don't have to worry about it. Again, one disadvantage is you lose that deeply granular control over your infrastructure. If you were using your Cisco router managed switch and you were able to program it, you have a lot of skill set in that Cisco area. You don't get that granular control because you have to use whatever appliance Microsoft is using. So that's another disadvantage you would get. So you understand shared responsibilities, you understand the different layers of responsibilities and service workload. So we're going to move on to serverless computing, and we're getting towards the end of chapter 1. Now, serverless computing enables developers to build applications faster by eliminating the need for them to manage resources so they could focus, they don't have to focus on infrastructure needs. I just referred to that briefly and said it's also referred to as serverless computing at a platform as a service level. Now, one thing I want you to understand, it doesn't mean that servers are not available. It just means that you're not responsible for those servers. So it is referred to as serverless computing. We'll talk about the different or the most common types of serverless computing functions. If you're coming from a developer background and you used to write scripts in Java, C Sharp, Python, then you will be very familiar with functions. Logic app is the same thing. It's an event-driven trigger, just like a function, and it's designed to solve complex orchestration problems, mostly workflow problems. Now, if you look at, you could write small event triggers, event-driven snippets in your favorite scripting language, and these stateless code can come into state and execute, and it toggles between state and stateless mode and execute for you. So for function, it would be a small specific code with a specific function. For logic app, it's a little more complex. It's designed to solve automation processes in workflows. Now, again, you could bring your own scripting languages. The most important thing I want you to understand is that there's a lot of support for Logic App in the marketplace. And again, the marketplace is a third-party Microsoft operated site that you could go to purchase third-party solutions that can complement your solutions in Azure. So let's go ahead and move on and see. Now, identifying service cases. A big part of the Azure setup is we just spoke about shared responsibilities and different types of services. Your ability to identify those services and where they would fall based on the workload and what you're trying to do on the pyramid, that's a part of the exam structure. You have to be able to identify them. Now, a subscription in Azure, I want you to understand, it's really your main account. You need an account or a subscription to function in Azure. In most cases, you'll get a free account or a prepaid or a postpaid account. It matters not, you still have to have a subscription in order to use Azure. Now, let's take a look at deploying application in situation where the company needs control over the operating system and security patches on the virtual machine. Only an administrator could do that. So that would happen at what level? It should come to your mind. It would happen at the infrastructure as a service level. That's where you're able to do your compute, create virtual machine, your servers, and then you could load your operating system. You could provision that virtual machine, and then you could use it. We'll talk about virtual machine later on. A virtual machine is just a computer, and virtual computer that emulates a physical computer, but you're using it over the internet through your web browser. We'll talk about virtual machine a bit more as we go drill down into the course. Now, we would not be doing that at the software as a service level because that's where you just log in and go. At the platform as a service, you don't configure anything. It's serverless computers. You are just a developer that focuses on writing codes. So it is definitely infrastructure as a service. So that's a use case I want you to understand. Now, if you need a database as well, or you have some software to develop. Once I use those two terms, you should realize you're at the platform as a service level. Now, again, similarly, your email, if I spoke about email, you understand that's a paid or a free subscription that you have to log in with a username and password. You don't have to worry about the back-end process or how the software is maintained. You just log in and use it. That's a software as a service level. Now, what if you need absolute control over all your resources? You want to have full control over them. Now, that is on-prem. That is when you have your own data center and you're responsible for everything. So this is a good use case. It's a good way to develop an understanding of how the Azure test is structured. You have to understand use case scenarios. Now we're going to move on and I'm going to be talking about the computing, some more cloud computing as we wrap up this chapter. But before I do that, I want you to understand the evolution as we go through from dedicated servers, a single server like the one we upgraded in the vertical example. Then we went to virtual private servers, then shared hosting, and then we went on to cloud hosting, public and private clouds. So let's take a quick look at the evolution so we get a better understanding of where we at with native cloud or public cloud. Now, a dedicated server used to be one physical machine dedicated to a single company. So you'd have a big server that's running online with your web application, You remember America Online, one big server, you're running your own application. This was very expensive and comes with high maintenance, but it also carries a high level of security if you have the right expertise in house. So that's where we're coming from, dedicated server. In a sense, we're still there. I'll explain that later. Now, virtual private network, it's still one physical machine dedicated to a single business, but this server is virtualized. We talk about hypervisors. If you're coming from a Windows networking background and you have experience with that, that's what we're talking about, hypervisors. The ability to create multiple virtual machine, virtual computers on a single server. Now, one machine was running a web application independently, but you have unique virtual machine that could run different application. That was the next step up. Then we move on to shared hosting. One physical machine again that share many businesses on a rental basis. This was very inexpensive and also very limited. There was no parity between tenants or no equity among tenants. And what that is, if someone has a really large workload, say for example the Olympics was going on in China and you have a couple thousand people using the server, all those resources would go to the Olympics committee and all the other tenants would be starved for resources. So there was no parity. So that's when we have to come up with a better solution. Now we're going to look at the umbrella system that is abstracted into a plethora of cloud hosting services and tool, which is really the public cloud. Now cloud hosting is very fluid. It can scale rapidly, as I discussed, and massively. It's super elastic, it's extremely secure, it has ironclad protection, it's very cost effective, and it's highly configurable. So that's where we at now, which is cloud computing, and that's what we're going to be talking about. Okay, so let's move along. Now, next we have private cloud, which is your on-premises solution, your on-premises data center that functions similar to a public cloud or native cloud, but with just one tenant. You're the only tenant. It's your resources. It's your data center. You are responsible for anything. There's no sharing going on with any other tenant. So that is the private cloud. So you understand cloud hosting, you understand the private cloud, and we're going to talk about a public cloud, which is where Azure comes into the picture. Now, the public cloud is also called native cloud, so the terms are used interchangeably. In Azure, it's called public cloud. In other solution provider, they refer to it as native cloud. That is the key difference between the two, but they are practically doing the same thing. Now, OpenStack is a solution that is able to help you create and manage clouds. So if you're running your own private cloud within your on-premises, you would use OpenStack as a solution to set up and manage your cloud service provider. Remember the name, OpenStack. This is the symbol or the logo on that side. So you just need to remember that OpenStack is the solution for managing your private data center. Now, let's take a look at another type of cloud. It's referred to as the hybrid cloud. So we should talk about the private cloud, the public cloud. We also have what is referred to as the hybrid cloud, and you should get the gist of it. It's a combination of the private and public cloud with two technologies merging. So you're using on-prem and your public cloud service provider to form a new type of cloud solution. It may be a situation where you need to keep certain resources on premises either by regulation or company policy. So that's a solution or a situation where you would need an hybrid solution. Now let's move on and talk about hybrid clouds. They're connected using Express Route. Now Express Route is a different solution. Remember, Open Stack is used to actually manage the cloud. Express Route is a really fast low latency connection between two sites. So ExpressRoute is what you would need to connect your on-prem data center to the public cloud service provider. Understand it. We'll talk more about ExpressRoute further down. This is just an example. This is an overlay. This would be your Azure cloud. This is your ExpressRoute connection at that end, and then this is your ExpressRoute connection at the other end, which is the customer data center on site. So you get an understanding of what ExpressRoute is and what OpenStack is. Those are two common technologies in the public cloud or native cloud arena. You should get familiar with those two terms. Now we're going to talk about cloud concepts on model CrossCloud. This is not on your exam, but it's important to understand. It is not an hybrid cloud. It is a combination of more than one cloud service provider. So if you're using AWS and Azure for some particular reason, you would use the Azure Arc to provide a bridge between the cross cloud services. And you also have xCloud that could be used as a bridge as well. And this is the logo or the symbol for a cross cloud solution in Azure. Now I'm just going to wrap this chapter up just by doing a cloud model comparison so you get an understanding. I'll do it vertically so you understand the different concepts. So for cost, it's most cost effective when you use OpEx instead of CapEx. So the public cloud is cheaper or less expensive. With the private cloud, it's more expensive because you have to manage everything. You have that huge upfront expense that you have to incur out of pocket upfront. Hybrid cloud would depend on what direction you lean the most. So it could cost more or it could cost less. Security. This is done for you by default if you're using a cloud service provider. If you're on premises, you're 100% responsible for your security. In a private cloud, again, it depends on how much you lean to the left or right, but you have to have two skill sets to maintain. You would need your on-premises skill set, and then you would use a cloud service provider. So the security depending on how much you're leaning to the left or the right. Now, configuration. You have limited configuration because the cloud service provider controls most of the configuration in the public cloud. In the private cloud, you have full configuration. Again, with the hybrid cloud, you would need two skill sets, your on-premises skill set, and then you'd have to understand the cloud service provider technology that you're working with. Knowledge base. In the public cloud, you only need to bring your developer skill set or your knowledge of Microsoft Excel to do your macros. Additionally, for the private cloud, you'd have to have knowledge at all levels of the cloud configuration because you're responsible for everything. And for the hybrid, you would need to know all the levels of cloud configuration for your system in the cloud service provider. So we come to the end of chapter 1, which is going over general cloud concepts. So we're going to start chapter 2 next, where we will be talking about Azure specific resources and tools. Again, I want to thank you. My name is Errol Morris, and I'll see you in chapter 2. Okay, welcome back. Again, my name is Errol Morris from NetMerge, and I'm your instructor for the Azure AZ-900 fundamental tutorial. We are at chapter 2. It's a very exhaustive chapter. It shouldn't be it just has a lot more topics to cover for you to get an understanding. So it's the most exhaustive chapter of all the chapters. We're going to be talking about it pretty shortly. We're going to be talking about architectural components. So we're going to look at the physical nature and makeup of Azure. So this is specifically about Azure from here on. Now, in my opinion, they want us to start talking about regions and pairs. You don't know what regions is, and you don't know what region pair or region replication is. So what I'm going to do, I'm going to do a quick overview of the overall infrastructure from top to bottom and give you an hierarchical overview before we talk about the different components. So I think it's better because they want to start in the middle. So let's get started. At the highest level at the top, we have what is referred to as the Azure Zone. This is not a part of the physical makeup of the server or the infrastructure IaaS. It's really designed for grouping, for billing purposes, and data transfer rate that is charged in different zones. Then we have the Azure Geography, which is the second highest tier, and it's used for data residency, sovereignty, compliance, and demarcation zones. So if, for example, in the UK, Facebook is not allowed to take data for their customers outside of the country, that would be a geographic location, and that is what geography is for. Again, it's not a part of the physical infrastructure. Now, when we talk about regions, region is a point of resilience and service that is made up of a minimum of three separate availability zones. Now, what is an availability zone? In Azure, an availability zone is simply a data center, a physical location, a physical building with servers and equipment with their own physical security that Azure uses to store information and provide you with cloud services. So a region is consists of three data center in general, and this is what is referred to as an available region in Azure. We'll talk about region with availability zones later on, but I just want you to understand what a region is, and I'll use a diagram to drive the point home in a few. Next, we have at the bottom of the pyramid, which is the availability zone, and it's a data center, as I mentioned, and it's a fundamental part of the structure. So it's a core part of the Azure infrastructure. So now that you understand what availability zone is, what a region is, what a geography is, and what an Azure Zone is, I'm going to start talking about an availability zone to give you a little more understanding. Now, an availability zone, as we have come to know it, is a data center with a physical security, physical server, staff, networking, etc. So it's a physical building. Now, each server or VM in an availability zone must belong to what is referred to as a scale set. So what we're getting to now is how a scale set is used to provide redundancy when we're doing updates or if you have a failure. So a scale set is a combination of what is referred to as fault domains and update domains, and we're going to be talking about them in real simple terms. So these are logical groupings used to promote resiliency in both planned and unplanned situations. So a planned situation would be done when you're doing an update, and an unplanned would be a disaster or situation. That's what that means. Now, I want you to understand this is what a region would look like. It would have three physical buildings, three availability zones that are connected to each other. It would be better understood with this diagram. This is a region consisting of three availability zones. So each availability zone or data center is a physical building with a physical security, your technical security, your own cooling system, your own networking, your own electricity, and they're connected with high fiber optics cable, low latency cable. So three availability zone would make up a region. Now these three folders that I'm showing you here is your Excel file that you created. When you create an Excel file in an availability zone, you get three copies of it for security purposes and backup and recovery on one availability zone, and that types of storage is called LRS, and it's local redundancy storage. I'll talk about it some more. Now, an Azure region is deployed approximately 300 miles apart. So this is one region. Another region within an Azure geography would be approximately 483 kilometers apart. So I want you to understand that. And again, Azure has approximately 60 regions. Not all regions have availability zones, and only 23 of those regions are actually available to the public for use. Now, we also have 22 different geographies in Azure with 4 billing zones, and we'll talk about the billing zones. And remember, they're for data transfer rate, they're logical groupings, so we'll talk about that. And LRS is local redundancy storage. So 3 copies on one Availability zone is referred to local redundancy storage is LRS. We'll talk about some different storage types so you understand it a lot better. Now, what are special regions? There are also some special regions that are mostly government regions designed to meet extra special compliance standards and legal requirements. I want to you to understand that. Now, an example is the U.S. Department of Defense Central, U.S. Government Virginia, and the U.S. Government in Iowa. We also have these special regions in China East and China North as well. Microsoft does not control those sites directly. They do it through a special arrangement with a company called 21 Vianet in China. Microsoft is not allowed to provide infrastructure as a service and platform as a service in China. They could provide software as a service, but they can't provide those two services. So they have to do it through a third party. Now let's look at Azure Regions. Now, Azure Service Regions are divided into two main categories, recommended and alternate regions. Now, that is why we only have 23 regions, because the alternate regions, you're going to understand they're not fully staffed and not all have availability zones. So, recommended region of the broadest set of available capabilities to support availability zones now or in the future. So they are already up and running and can expand on. Alternate zones are referred to as other region, and they operate within a data residency region with boundaries. These regions are labeled as other in Azure, and they do not have availability zone. That's the huge difference. Now, general availability is when a service is considered ready to be used publicly by everyone in the public. Azure Cloud services are grouped into three categories that determine when a service is available. Now, a foundational service is when a service is generally available at the moment or within the next 90 days in both regions, in a recommended or other regions. Now, mainstream in is in all recommended region in the same time period, but a general availability are not they are on demand in the alternate regions, so they're not available in both regions, as is the case with the foundational. Now, strategic services are not available in any of the region. They're only available on demand, and they use special hardware in those regions. So those are the different types of regions. I want you to understand them. Now, these are the 23 zones that are available, 23 regions that are available in Azure. You could take a look at them and familiarize yourself with them. We will be talking about US East and North, and US 2 is now available. That's a new region in Atlanta, Georgia. Now let's move on to Azure Geography. It's a discrete market with one or more regions that operate with data residency and compliance boundaries. So each geography meets a specific data residency. It's a demarcation zone. Remember, I explained that in the beginning. So an example of geography would be Canada, United States, Mexico, Brazil, or Azure government. This is an example of a geography. It has one availability zone and a full-blown region. Now let's look at Azure Zone. Remember, these are zones that are designed for billing purposes and data transfer rates. That's why they are created. They're not really, they're logical grouping. They're not physical grouping. So you see where Zone 1 covers the countries it covers. Zone 2, Zone 3, and Zone 4 covers Germany Central and Germany Northeast. So you could have an understanding of how those billing zones are created. Now let's look at a philosophy called cross-region replication. And what this is it is designed for business continuity. So if we're able to pair two regions with 6 availability zones, you get better redundancy. So it is designed for business continuity and disaster recovery. And remember, when you see the word disaster recovery, it's the ability to tolerate a fault. So with 6 availability zones in a pair of regions, you're highly available and fully capable of withstanding a natural disaster or any type of fault. So that is what region replication is, and I just want you to understand cross-region peering. Now, you're not able to choose your own peer within a region. Azure actually choose those pairs for you. Now, one more thing I want you to understand. Remember, we talk about getting 3 copies of your files shared or stored in one availability zone, and you get SLA of 99.99, which is referred to as 11 nines. We'll talk about 11 nines and nines when we get back to SLA, but you get 3 copies. This is referred to as local redundancy storage. Now, zonal redundancy, it's easier to remember as regional. It's really redundancy storage where all 3 copies of your Excel files would be stored in 3 availability zone or 3 separate data center, as I show you with those folders. They were on LRSs in one area. With the ZRS, you would get LRS but in all 3 availability zones. So you get 12 nines because it's increased the amount of 9 and it increase your availability. Now GRS, which is geo-redundant storage, you get what is referred to as synchronous, which is real-time storage, using LRS in AZ in your primary region. So remember, we're talking about region pair. So in the first pair, you would get LRS storage, which is 3 copies in one availability zone in real time, and then asynchronous, which is delayed backup. You would get that in another available zone in a second region. So you would have 2 LRS storages, one in your primary region and one in your secondary region when you're using region pairs. And remember, region pairs are for business continuity and disaster recovery. Now GZRS, it's a little different. You get the same secondary storage asynchronous in a different AZ, but what you get is you get GeoZone redundancy storage. It gives you synchronous storage using ZRS. What is ZRS? Storage in all AZs. So in your primary zone, instead of getting one storage in one AZ, as in the case with GRS, with GZRS, you're getting 3 copies on 3 AZs in your primary zone, and then you're getting another backup copy in your secondary zone on a delayed asynchronous manner. So that's the difference between the types of storages in Azure. Let's move on. Again, I told you this is an exhaustive chapter. There's a lot to cover. These are some of the benefits of region pairs. You get real-time storage in your primary region and delayed storage in your secondary region. You get high availability and exceptionally high redundancy. You get durability because you're pairing, so you're getting a lot more. And region pairing is not done by free. For some services, you get geo-redundant storage, which is by default, such as your blob storage, but for other services, you would have to pay for it and you would have to plan for it. Now, you will get recovery sequence. Priority recovery sequence as a feature in region pair benefits, and I'll explain that. If you have a pair of regions, let's say one is A and one is B, what Microsoft would do if you have a geo-wide disaster that wipes out the US and they're gonna be recovering, they will bring one pair in each region up first before they go back and do the second pair. So if you have pairing replication, you would guarantee that at least one pair of your region would be online first. So that's what recovery sequence is. I hope you understand the concept. Next, you get sequential updating. You won't understand this one fully as yet, but once we get deeper down in the course, you would understand sequential updating. When we talk about updating domains, and the time frame between the domains, you'll understand the term sequential and chronological a lot better. But you get that with region pairs. You just need to understand that. You also get physical isolation. Remember, they're 300 miles apart. So if you have a disaster, a natural disaster, 300 miles in the US Northeast, let's say for example in New York City, you would have to go down to Virginia before you would have exceeded that perimeter. So it's very unlikely you'd have a disaster that stretches so far. So you have isolation and a buffer zone in the 300-mile barriers between the different sites. And you also get mission critical composite SLA. When you do the region pairing, you're getting what is referred to as composite SLAs, 16 nines, and you can see the nines are going up. We'll talk about composite SLA in chapter 6. Now let's keep going. There's a lot to cover in this chapter. This is a general overview of what a few region pairs would look like. And I want you to understand that region pairs, you get three AZs in the same regions for LRS. Now you get three copies on one AZ as LRS. Now region pairing is not by default for all services except for geo-redundancy service. So if you have a service that is marked as geo-redundant, you get region pairing on that service by default. Additionally, you cannot choose your own region pairs. It would be ambiguous and a lot of confusion for Microsoft to figure out which pair is you choose, which is your primary and which is your secondary. So you're not able to choose your region pairs, and that's a good thing. Okay, this is a look at the different regions. You could look at them at your leisure, and this is a look at the secondary region. So there are 25 regions that you will get to cover. I just want to go back and show you something. I just want to point out something with the different regions really quick so you could understand the concept. For Brazil, if you realize Brazil South is pairing with US Central, they only have one region in Brazil, so region pairing is very difficult. So they paired with South Central US. The difference is this is not bi-directional. South Central US paired with another region within the United States. They don't do backup in Brazil. You need to understand that. Same scenario as is the case with Singapore. So two countries, Brazil and Singapore, they have a little difference when it comes to region pairs. I want you to understand that. Okay, let's move on. We got a lot to cover in this chapter. Again, it's the most exhaustive. Now let's take a look at availability zone. We're going to be talking about default and update domains, so you get an understanding of how transparency is maintained in Azure when a fault and an update domain is taking place. Now you have to understand region pairing and what the key components and benefits are. Let's get to look at the availability set, and an availability set is a combination of fault domain and update domain. What is a fault domain? It's a logical grouping. Again, it's a logical grouping of subsystem of virtual machine that share the same networking hardware. So think about it as a stack or a rack of servers. Now, let's say you have 10 virtual machine in a rack, or 5, or however many, but you must have at least 2 to create what is known as an availability set. So if you're looking at the rack, you have 5 servers in the rack. They're sharing the same power source, the same switch, the same cooling system, the same switch for your internet, and that there's a single point of failure for that rack. What this is saying is you can only have 3 racks of server, 3 vertical racks, or you could look at it as a column. Now let's look at how the update domain is set up logically. It's similar to the fault domain, except it goes horizontally. So one is vertical, one is horizontal. So you could look at it as rows and columns, and both of them would make up an availability set. So you would have a XY coordinate, so to speak, or one is perpendicular and one is parallel. So you get an understanding. So the rule is you could only have 3 columns and up to 20 rows. So 20 rows is your update domain and 3 columns is your fault domain. Now let's look at how the magic comes together with this diagram. Now this is one rack, domain 0, Domain 1 is your second rack, and Domain 2 is your third rack. You have 5 servers in each. The first server in your domain 0 is referred to as your update domain. So if you're doing an update, it would go across horizontally, and it would be update virtual machine number 1, 6, and 11 at the same time. Now remember, I told you to hold on to the concept of chronological order and sequencing. Well, this is it at play. When the first update domains runs across horizontally, it would wait 30 minutes for these 3 machines to come back up before it would move on to the second domain, the second update machine. So that's your sequencing and your chronological explained in detail. Now, if this should fail when you're doing an update, this is your redundancy now. You would still have 4 virtual machines in each rack. Now, if an entire fault domain should fail, say for example 0, you would still have fault domain number 1 and fault domain number 2. And this is how your update and your fault domain is able to maintain transparency and high availability during a planned on an unplanned situation, as I mentioned before. So you should have a good understanding of how they work at this time. Now, let's look at the benefit of having the availability set, which is a combination of fault and update domain. You get high availability, you understand why. One fault goes down, you have 2. One domain goes down, you still got 4. So that is high availability. There's a lot of redundancy built into that. You get the sequential update. I explained that. You understand that. You get the fault tolerance for disaster recovery, and I explained that as well. And you also get the high performance and low latency network connections from the different AZs connected with fiber optics cable. You also get automatic zone redundancy and zonal or hybrid redundancy at the region level. And I explained to you what zonal redundancy is. It's really all 3 AZs having a copy or all 3 data centers. So you understand what that is as well. So let's move along. Again, this is a very big chapter. You want to understand it. What I'm going to do at this point, I'm going to give you a look into Azure. It's your dashboard and unified command center. You use it through your actual web browser, your favorite web browser, and it's a graphical and intuitive user interface that you would use to interact with Azure. You can use Azure Portal to create new resources, to manage existing resources, to delete deprecated resources from your account. It is really your control and your user-friendly tool. It's not always the most appropriate place to do everything, but it is your main landing pad. So I am going to break and we're going to take a look at your Azure Portal. All right, let's take a look at Azure Portal. Remember, I talked about subscription and I mentioned that you need at least 1 subscription. You can only have 1 subscription in Azure. Well, I already have a subscription that I use for training, so I won't be able to log into another subscription. But what I'm going to do, I'm going to try to get as far as I can with my existing subscription, just to give you an idea of how it is done, how you could set up an account. Technically, if you're living in the US, you should get a $200 credit the first time you set up Azure. So you could use it to actually, play around with the resources and system to get your feet wet with Azure. So what we're going to do, we're going to type in Azure Portal to get started. So when we type in Azure Portal, we should see a list of pop-ups that we could select, and I am gonna select this one. You want to make sure it's the right Azure Portal and you're using Microsoft Azure. I'm looking for the Azure sign in and billing. So once you get there, it should ask you if you want to go to the portal. It asks you if you want to create a free account, and you click yes. Then you could start click free, and you could follow the step-by-step procedure. It's very simple. As you can see, I already have an account set up, so I'll be using that account. Now, see, it's telling me that I already have an account, so I'll just go to the pagey, and it's going to take me to the Azure landing page. I only want you to get a feel and get a look as to what Azure looks like. This is the Azure page. I could click home and it will give me a set of resources and the different resources that we could look at. So we're going to be talking about resource group. We're going to be talking about how to create it. We're going to be talking about functions. We're going to be talking about management groups. We're going to be talking about VNets and networking. So it's really good that we understand. And we spoke about virtual machine. We're going to be talking about it some more. So at least I want you to get an understanding of what the Azure portal looks like so you could get a feel for it when we start typing and working inside of it. So let's get back to the main course, and we're going to come back to the portal downstream to do some basic work. Now let's talk about resource group. Now we spoke about resource group briefly, but resource group is a single logical collection of resources. So what is a resource? A resource is anything that you could create and use in Azure. So a virtual machine is a great example of a resource. It's something you could create and use in Azure. So a resource group would be a group of resources such as the virtual machine you create. It could be your database, your SQL database or Postgre database. It could be an application that you create using your favorite programming language. Anything that you want to group for a specific purpose can be in a resource group. Now, a resource group provide a granular management resource that you have that you could use to manage your subscription. So if you have a main account and you have a subscription for testing, and you have a production team, you could have one for production, you could have one for accounting, you could have one for IT. So all your different groups could have a different subscription group for managing. So remember, the subscription group is for managing the resources that are in the particular group. So this is an example of what a subscription or resource group looks like. You have your virtual network, you have your virtual machine, you have your internet connection, and you have your database. This is just a plain example of a resource group. Now, you might not understand the concept of a resource group if you're a small company, but if you're an extremely large company with thousands of groups, you'll understand why it's important to have these resources in groups so you could manage them in Azure. So that's resource groups. These are some of the benefits which you will get with resource group. We'll talk about these benefits downstream. You're allowed to manage resource cleanly, and the word cleanly is what we're going to be focusing on. You have a logical formation. You could create, you could replicate, you could organize. So for example, if you have resources you're using in New York, you open some new offices in Virginia, you could replicate those resources real quickly, and that's where the word cleanly comes in. If you have to dispose of those resources, you could do it seamlessly and again cleanly. If you want to organize those resources to track costs, again, you could do it cleanly. So you understand what the entire cleanliness is all about. Role-based access control, I haven't spoke about it yet, but it's just controlling the user and to decide what their access level is, what they can see and what they cannot see, what they can do and what they cannot do. That is what role-based access control is about. And again, you could set and track budgets for projects using resource groups. So you get a good feel as to what a resource group is and what you could use it for. Now, I want you to understand, we look at the Azure portal, you could create a resource group there. You could also use a CLI, which is a command line interface if you're using Linux, Mac OS, or Android, and you could use Azure PowerShell if you're using Windows. So if you're coming from a programming background and you understand scripting and you're familiar with writing small scripts and codes, you should be at home using the CLI or PowerShell for scripting to create your resources as well. Now let's look at the Azure subscription in detail. Again, I said you need a subscription, and your subscription is your main account really in Azure. It's the primary account. You could only have one primary account, as you could see in my case a moment ago. I could not create a new one because I already have an account. Now, this is a general overview of what the main account would look like, and then you could have subscriptions for your different departments. So this is your development, this is your testing, this is your production, and they all have a subscription. So the word subscription, the way it's used by Azure, it's a bit ambiguous, but you'll understand the concept once you get along, and it's often used in an implicit way so you can understand it. So Azure uses the word, like I said, implicitly, and you'll get to understand it better. Now, this is a management group. It's actually a higher tier than the subscription group. Now, a company or an organization or a division might have many subscription group, but you could only have one management group for an entire organization. So this is the highest level of control you would get in an organization. So if you want to set broad policies or broad compliances, if you're in the UK and you want to set a nationwide compliance and policy for your user data, that's where you would set it, at the management group. It's your root management group. I want you to understand that. So the management groups sit at the top of the hierarchical chart, and it sits above your subscription group, and the subscription group sits above your resource group. So you get an understanding. Here's a general overview of the management group. It sits on top of the subscription, and then you have your resource group for your different department, and you also have your individual resources. You could set control at the resource level as well. Now, this is an even broader example for a bigger corporation or a bigger organization, but the concept is still the same. Now, let's look at the benefits of a management group. You get Azure Management Groups allows you to create policies and compliances at a very high level. You get management groups also allows you to set role-based access control. We spoke about that. What type of access each group would have to a particular resource. You might not want somebody having access to your accounting department, so you won't give them access to that. You might only give them read access to your Excel file. You don't want them to update the file. You want to be the only one to update the file. That's what role-based access control is about. If you want to provide certain access to many subscription, the management group is where you want to do it. A management group gives you enterprise, large, wide-scale management overall in Azure, and that is a great control to have. Now we're going to move on, and we're going to look at Azure Resource Manager, and we're going to look at something called infrastructure as a code. So infrastructure as a code allows you to manage and provision a complete data center using machine readable codes or script rather than physically creating these resources manually. Remember when I mentioned that using the graphical user interface in Azure is not always the best place to create a resource, and I explained what a resource is? This is an example. So if you want to create an entire infrastructure, you want to create like 1,000 virtual machine for the Olympics, and you want to create 1,000 virtual machine, and you want to network them together so they could communicate, you would use code to do that. You would use script to do that. This is what this is actually saying. You would use script to provision it, and it could deploy it a lot faster than if you have to manually create each of those in Azure. ARMS provide management layer that enables you to create, update, and delete resources in Azure very easily, and again the word cleanly. So you're able to do it very cleanly and very timely. Now I also want you to understand something about the Azure Resource Manager. All access, if it's coming through your APIs over the internet or your SDKs, it is routed through the Azure Resource Manager. So every resource would have to be accessed through the Azure Resource Manager. So that includes your database, your web application, your virtual machine, your service management, or any other resources in Azure. It would have to get authorization from the Azure Resource Manager before you would be allowed to access it. So you want to understand that apart from creating an entire infrastructure, it also controls access to each resources. So ARM, remember it, Azure Resource Manager, will be seeing it coming up a lot. Now Azure Resource Manager will then authenticate and authorize each request before connecting to the resource, making them available. You also want to understand that there are plenty built-in templates. They're built in JSON, the ARMS template, that are available in the marketplace as well. So if you're going to deploy a Linux machine, you probably could use an image or something from the marketplace that is already prepared and easy to use, so you don't have to write codes from scratch. So there's a lot of support for the Azure Resource Manager. Now here are some of the Azure Resource Manager. You get a rich collection of predefined open source declarative JSON templates. So we spoke about that. You get control resources, group level versus service level control. You get consistency in deployment cycle when you deploy solution. So if you deploy an entire infrastructure in New York and you open an office in Virginia, you could deploy the same infrastructures. You get defined resource dependency, so they are deployed orderly. So if you have one resources, if you have your virtual machine and your database depending on the virtual machine or vice versa, it will know to deploy those resources in order for you. You get native role-based access control over your resources being deployed. We haven't spoke about tags. I will be talking about it a little later, but it's the most granular way of doing organization in Azure. So we'll talk about tags. You can use tags to merge resources. We'll talk about it. And critical resources. We haven't spoken about locks either. I'll talk about locks very shortly, so you get an understanding. Again, it's a really big chapter. It has a lot to cover, and we have to go through it at a much faster pace than the other chapters. Now, this is your Azure Resource Manager benefits. You want to get familiar with them and try to understand them as well. Now we're gonna talk about virtual machine, app services, container instances, Azure Kubernetes services, and virtual desktop. So let's talk about virtual machine. They are virtual computers you can create very easily and quickly to emulate a physical computer. You can configure and provision a virtual machine using hypervisor technology provided at the infrastructure as a service level in Azure, and we spoke about that in detail. At that level is where you can create and configure your virtual machine. When we spoke about elasticity, we talk about virtual machine scale set. It's a group of similarly configured virtual machine. Remember, when you scale up, vertical scaling, you upgrade the machine. When you do scale set, you create 1,000 of the same machine for the Olympic in one go. So that is what scale set is. It's a set of virtual machines scaled together with the same configuration. It is also used as a load balancer. So if you have a demand for new more computing power, then you use the scale set. If those demands subside, you could get rid of the machines that you're not using, so you're not wasting resources. So you get an understanding as what the virtual machine is and the virtual machine scale set. Here are some of the benefits. Zero capital expenditure. Okay, those are some of the benefits you get with a virtual machine scale set. All those benefits, okay. Again, load balancing and auto scaling is the one you want to focus on. It will allocate and deallocate virtual machine on a need basis systematically. With scale set, you get centralized management and consistency across the board. So these again are more benefits you get from using virtual machine scale sets. All right, now I'm going to look at Azure Container Instances. These are lightweight virtualized virtualized environments like your virtual machine, but with a lot more flexibility. You can quickly create and deploy Azure Container Instances with a lot less effort than you would with a virtual machine. So we're going to be looking at the Azure Container Instances. And when I said the container instances are similar to the virtual computer, is the fact that you could run operating system in them. So let's take a deeper look at them. With containers, you can simulate multiple operating systems on a single virtual machine instead of being restricted to one operating system per VM when you're using a VM. So further to that, you can run multiple instances of containerized application using a separate OS for each on a single VM. So you could have multiple containers on a VM. They're easier to set up, and each container could be running their own application. So you get more out of containers than you would for a VM. They're easier to set up, and you get more out of them. So it also provides a huge upfront cost saving for you. So unlike VM, where you don't have to manage the operating systems with the containers, you don't have to do that. Now think of VM scale set as a rapid solution change in demand. So if you have an increase in demand, VMs can do that. Similarly, containers are a fluid solution to demand for diverse changes. If you have a lot of application that you want to run on a single machine, or you could use containers instead of using separate virtual machines for them. So that's the difference. One is able to scale for demand for more resources, and one is able to scale for diversity. So if you have a diverse need, you want to draw for the containers. Now Azure Container Instances run on Windows and Linux, so that is good. So you could use them in any environment, and you want to know that Windows or Azure is using the Docker container. So if you're familiar with the Docker engine or Docker as a service, that's what Azure is using for their containerized application choice. Now um, let's take a look at orchestration now with Kubernetes service. So Azure Kubernetes is a mainstream container orchestration service built on the open source Kubernetes system. So if you have Kubernetes, they're like skill set. It allows you to scale massively. So if you have a great need, you're a large organization and you need a lot of containers on a large scale, you want to use Azure Kubernetes services. The containers, they're made possible by microservices architecture. We'll talk about microservices, and you want to understand microservices. If you're coming from a developer's background, you understand the solid design principle. The S is for single responsibility. That's what microservices are. They're small piece of codes or services that only have a single responsibility, so they are able to do it in a real agile manner. So remember that if you're a software developer, you recall the solid principle. It doesn't matter what language you code in. Microservices are just that, one single responsibility that it could do really quick for you. And again, we're using the Docker engine for expansive Kubernetes as well. All right, so let's see if we could move on. Let's take a look at app services. Azure App Services, it runs through your web browser at the HTTP layer 7. You could quickly build and use application, RESTful APIs, any programming language of your choice, and you could do this at massive scale. Now, Azure App Services offers auto scaling as well, so it's very elastic, and it supports both Windows and Linux development and enables automated development from GitHub, Azure DevOps, GitHub using the GitHub Actions or Azure DevOps pipeline for deployment. So you get good service from your app services as well. These are some examples of the app service where you can run them. Okay, with your Logic apps, your functions, your Docker containers, your Linux web pages, or your Windows web pages. That's where you could use your app services. Now we want to move on and we want to take a look at Azure Fabric. It's one of the microservices mastermind in Azure, and it is run using containers. So what we want to do is look at some of the examples of what you could use Azure Fabric apps, or as a matter of fact, what it is used for. Azure Fabric apps is running Microsoft SQL, Azure Database today. It's running Cosmos DB. You could use it to run Katana. It's running Microsoft Power BI, Microsoft Intune for registering your devices. It's also used to run the Azure Event Hub, the IoT, Azure IoT, Dynamics 365, Skype for Business. There are many different services that they're using the Fabric Azure Service Fabric to run, and it's a good example of containerized services and microservices in Azure. There's your service app. All right, let's move on. That was not on your course outline, but I figure I'll show it to you. Let's look at a virtual desktop. Virtual desktop, or desktop as a service, it's a remote terminal emulator for your virtual machine. It can only be configured on Windows, but it can run on Windows, Linux, Mac, or Android OS. But you need to understand you could only configure Azure Virtual Desktop on a Windows in a Windows environment. Now, the Azure Client Desktop, it works across platform once you're able to create it, to execute and publish application. The virtual desktop containerized services use FS Logics to manage profiles. Each user and the Azure Virtual Desktop is managed using the Azure Virtual Directory, AD. We'll talk about Azure Virtual Directory very soon. Now, Azure Virtual Desktop uses reverse connect technology where the inbound ports to session host or VM is always closed. This connection type is far more secure than remote desktop protocol. So there's your Azure Virtual Desktop, and these are some of the benefits of your Azure Virtual Desktop. Now, the use of the Azure Gallery, it's another service that is in your marketplace as well that you could also use. So this is your virtual desktop. Those are the different services. Let's move on to the Azure Virtual Network. So we're going to be looking at networking now in a virtualized manner. It's Azure Virtual Network, for short VNet. It's a glue that ties your resources together in Azure. It allows your resources to talk to each other. Your virtual machine, your switch, your printers, they're all able to talk to each other using the VNet setup, you construct your VNet. So VNet is similar to your traditional on-prem networking infrastructure. So if you have experience with networking or system administration, you would be at home using VNet in Azure. Each VNet must have a unique name and a classless interdomain routing, which is called CIDR range. We'll talk about CIDR. It's not, I don't want to get into too much detail with it. I just want to give you a basic overview of the CIDR because we're pressed for time. But this is your SID range. The lower the SID range, which is the 16, the higher the amount of machines. So this is just an example. For a SID range of 16, you would get 65,336 machine. I gave you the starting point and the end point just as an overview, and I have some quick examples that I'm not able to explain in detail, but if you follow the logic and follow the range, you'll get an understanding. The thing that you need to avoid, to pay attention to, you need to try to avoid conflicts, and I explain how you could avoid conflicts by having the right number 2 and 3 in your subnet that falls behind your VNet. So your subnet must have a smaller SID range than your VNet. And remember, smaller means the number has to be higher. Now, to understand that, I provided a chart. You could look at that in your leisure to get an understanding why the smaller number generates a higher amount of IP range. Now, let's look at the virtual network diagram. This is your internet. This is your Azure infrastructure, and this is your public client-facing IP. This is your SQL server. It should always be on a private network, and you could see the IP addresses and how your network is structured. This is just an overview of what a virtual network would look like in Azure. Now, here are some of the core benefits of your virtual network. You get to route network traffic using the table for specific subnet. You are able to filter your network service group. We haven't spoken about that either. We spoke about Express Route. You understand what it is. It's used to connect your on-prem to Azure in an express manner. That's what Express Route is, real fast peering. You get the resource peering, you get isolation and segmentation. That is, if you want to isolate a different department, like your accounting department, you could isolate it and segment it into a different subnet behind your public VNet. You get internet communication using outbound public IP addresses. So there's a lot of benefits that you could get from your VNet. Now let's look at a virtual private network gateway, VPN. We're all familiar with VPN. You use it for trusted conduit to connect and operate over an untrusted area of network. So you're going over the internet. You want to encrypt and decrypt your data at end the source and destination end to make sure your information is secure as it passes through the private tunnel. This is an example of the how your VPN work, how it will go through the internet and how your information would be encrypted and decrypted. The thing I want you to understand is that VPN connection, you want to understand this for the exam. Site to site is on-prem connecting to Azure. Point to site is point is your endpoint devices. Just remember it that way. When you see point to site, point is referring to your endpoint, your laptop, your computer. So it's individual to Azure. Network to network is when you're connecting two networks together, and that is VNet to VNet. So you're connecting two cloud computing sites together. So that's network to network. It's very important that you understand when we talk about VPN. But just remember, point to site is your endpoint connecting to an Azure site. Now, these are the virtual networks. You can deploy a VPN gateway in one of two ways, policy-based, route-based. You want to understand the core difference between the two types. And that's the different types there. You understand how your data is packaged to go over the internet using your internet key exchange and your iSpec security. iSpec construct the transaction, and iSpec is responsible for protecting the contract by encrypting and decrypting them at the source and destination point. So policy-based gateway uses a static IP address. When you have that luxury, you could use policy-based to do that. When you don't have that luxury, you have a lot of different devices that are keep changing. It is too cumbersome to do. You use the route base. Now, express route. I spoke about express route before. This is a super fast connection between your on-prem and public cloud. I promise I will come back to it a little. With the help of a collation provider, you're able to deliver speeds up from 50 megabits up to 10 gigabits. That's super fast speed, and they're able to do that because they're not going over the traditional internet. They're using special layer 3 connection. As you can see, this is your cloud, this is your partner. You're doing a primary and a secondary connection using your Express circuit. This is your Microsoft Edge browser, and these are your different resources that you could use to connect using Express routes. So Express route, layer 2 data link with node to node communication, very fast, and layer 3 for your network layer, which provides addressing and routing between nodes on a multi-node network. So remember, Express route, you don't have to remember the details of how it connects, but you need to understand what Express route is used for. These are some of the benefits for Express route. You should try and remember at least some of the benefits as well, but you would need to know what Express route is for the exam and what it does. You don't have to know the intricate details for the exam. Now we're going to talk about storage. Now, if you're coming from a software background, we're going to be talking about container storage, which is referred to as blob storage. Now, if you're coming from a object-oriented programming background, you'd understand what is object-oriented storage. Now, this is the solution that Azure present as their object-oriented storage. It's called blob storage. You can store massive amount of unstructured data for direct web application access and usage. You have blob objects. It can be accessed over your OSI layer 7 through your web browser. You could access it using an API. You could use your Azure PowerShell or your client-side interface. You could use your Azure Storage client library. With blob storage, you won't need to provision storage in advance. You could just scale elastically, infinitely. So it's infinite amount of storage with your blob storage. And these are some of the things that you could use blob storage for. As you can see, there's a lot of different ways you could use it. All right, so let's talk about the blob storage and the different types and how it's constructed. Again, you're using a namespace. It's an object. It's a blob object. They're showing you how it's constructed. There are three main parts to it. You have the account, so for example, Sally, and then you have a container, which is the different folders. You could route your pictures to one folder. You could route your movies to one folder, and the blob is your actual JPEG or your actual AVI names that you could use for routing. So you get an understanding of the blob storage and a general breakdown. Now let's look at the different types, blob types. You have the block blobs for text and binary storage. You want to remember that. You also have your append blob. Remember, you're using object storage where you could append in abilities, so you could do it. It's great for things like login, where you want to keep login at the end. At each time you could use append. You have a page blob for random storage. So here's your blob. It's preferred as the ideal solution for storage. Now, Azure Disk Storage is virtualized storage using Azure Virtual Machine. We're going to talk about the different storage tiers, but we just want to go over the general concept of disk storage. So you can use it for your virtual machine and your VMware solution as well. So Azure Disk Storage offers high performance, scalability, high availability, security, and durable block storage for your mission critical solutions. Azure options include a choice of Ultra Disk, Premium Disk, Premium SSD, Standard SSD, and Standard hard disk drive. With this managed disk tier method, you only need to select a disk type and size and provision it for use. Now, Azure recommends using Premium Solid State Drive SSDs as you're operating. You cannot use Ultra Disk for OS. I want you to remember that. And you should only use them for storing high demand data. Ultra Disk, you use them for your databases and other high low latency needs. Now let's look at the disk storage and the different types. We have the hottest, we have the hot storage, warm storage, cold storage, and we have the associated disk types that are recommended for each. There's some low-level detail at the bottom you could look at your leisure, but I just want you to understand the different storage tiers. Now this is a Azure file storage. If you're used to file storage on your network, it's the same file storage in Azure. Same situation where you get your server message blocks, SMB, for helping to secure your data at rest and in transit. Now look at the libraries. You could read files over the internet. You can mount your Azure file shares concurrently using Azure or doing your on-premise deployment. So you could use it across platform. With the file sync, you can also cache files near their endpoint for faster latency, faster access. This end result is Azure File Share. Multiple VM can share the same files concurrently with reading and writing access with low latency. Okay, right, so there you go. I'll give you an example of the file share and how you could use it globally. The SMB. These are some of the benefits of using the file share. You get security at rest and while in transit. Now let's look at the Azure storage tiers that I mentioned real quickly. You want to remember these for the exam as well. You have the hot access tier, you have the cool, and you also have the archive tier, which is the coldest. So the hot tier is it costs more to store and less to access. It's used for high demand workloads. So it's always in use. So access is not very expensive, but it costs more to store. The cooler the tier, then the cost changes around. At risk for 30 days or more or less, it's a middle tier solution. It costs less to store and more to access. The coldest tier, which is the archive tier for long-term storage, has a higher retrieval fee because you have to get those disks spinned up and turned on for you before you use them. So it costs you more to access and it's cheaper to store. You want to understand access tiers, hot, cold, and archive tiers. You want to understand the concept. Now, I just want to go over these other types of storage really quick. They're not in the course outline, but I want you to understand them. You could look at them during your leisure. I want you to especially pay attention to the Azure Data Box and the Azure Data Box Heavy. It's an actual physical piece of equipment that is used to move data physically through a carrier such as FedEx or UPS in a secure manner. They're encrypted, they're great for migration. I want you to at least understand that, if nothing else. I also want you to understand the data lake and the storage tier for the data lake as well. All right, so that's storage. So I want to go through the storage real quick so we could look at the databases. So we have the Cosmos. It's a non-SQL database. It's really low latency, exceptionally fast, very powerful, very popular. Cosmos DB can handle super large key pairs of the data at any scale, they say. If you're looking for performance scalability, Cosmos DB is with a rich blend of ready-to-use APIs such as SQL API, Cassandra API, Gremlin API, Table API, and Azure Cosmos DB API for Mongo. It made Cosmos DB a serious lifting contender. Now we want to look at some of the benefits of Cosmos DB. I'm not going to go through the different benefits. You could look at them in your leisure. I just want you to understand that Cosmos DB is a good contender as a database, and it's working with 5 nines for business continuity. That's really good for SLAs. Now let's take a look at the next database. And this is the database that Microsoft is fostering as a solution. It's their database. If you're used to Microsoft SQL or Microsoft SQL SQL database on premises, it's really the same thing offloaded into the cloud. It's a fully managed SQL database management system. Azure SQL database provide domain-specific database administration with optimization abilities on the platform as a service backplane. So it's a full-scale database, very popular and very common. You could use it for graphs. It supports JSON, spatial, and XML format. So if you're familiar with SQL, you're at home with SQL Server. Now I want you to also pay attention at the available resources that you could use with SQL. You could use up to 80 vCore CPUs. Pay attention to that. It could surprise you on the exam as well. You could use up to 4 terabytes of memory on a single SQL database vCore based purchasing model. You can scale up to 100 terabytes of memory on a single server with a Hyper-V scale. So that's a different tier. So your core cost is microbillion. You're only paying for compute and storage time. You're not paying for the actual database for the duration of the time that you're using it. Now we talk about SQL Managed Instance. It's a highly intuitive service that enables frictionless shift and lift migration. So it's a migration tool to migrate from on-prem into the cloud. So you get an understanding of what it is. It's a sophisticated deployment service that combines enterprise engine with platform as a service architecture into a versatile SQL managed instance. The end result is the ability to move on-prem SQL Server into the Azure management instance. So it migrates with less stress and with the like pod capabilities. They might want instance scope features, for example, feature scope to the server and not to the database. Features such as Service Broker, SQL Agent, CLR, ML, Machine Language Services. You could get all those features when you're doing your migration. All right, so this is just an overview diagram, so you could look at it and get an idea of what the SQL managed instance can actually do for you during your shift and lift or your lift and shift. Now, these are three of the service tiers that you get with the SQL database. You get a general purpose standard. Depending on your workload, you should select accordingly. So you want to look at these features and look at your workload and match them together. Now let's move on to MySQL or MySQL. It's another option for database in Azure. It's well supported by Azure as well. We also want to look at the Postgre SQL database. It is also another service, database as a service. They're all mission critical databases that can handle really large workload. So they're like three data full blown managed databases and one non-SQL database in Cosmos DB that you could use in Azure. You want to look at the different service tier for PostgreSQL. Now we're going to take a look at the Azure Marketplace. I spoke about it so many times, and now we're actually get a chance to look at it. So the Azure Marketplace is an industry-leading third-party technology store that offers solutions to complement the Azure ecosystem. You can identify, try, buy, deploy, or interact with third-party vendors. All the add-ons in the marketplace undergo a rigorous screening process, so they're not just thrown at you. They actually went through a vetting process by Microsoft, and you also don't have to worry about a billing or having to deal with the different marketplace vendors. It goes through your main subscription or your root account. In addition to that, you could get consulting service, analytics, security, networking, storage, DevOps, high level categories you can explore for a solution. All your billing again is done through Microsoft. So you understand the power of the marketplace. It's really a plethora of resources that you could capitalize on that is at your fingertip in Azure. This is just an overview of what the marketplace would look like. These are the features app, and then below you would have your consulting services and solutions that you could select as well. I think we have came to the end of a very exhaustive chapter, and we should be moving now into chapter 3. It should be a lot easier in chapter 3, where we're going to be looking at different resources and different tools, but it's really a huge step forward. We won't have to expend as much time in chapter 3. It's a lot easier. We could go through it a lot faster. Again, this is the most exhaustive chapter, and we have come to the end. All right, again, my name is Everett Morris from NetMerge, and I'll see you in chapter 3. Okay, welcome back. Again, my name is Everett Morris from NetMerge, and I'm your instructor for the Azure AZ-900 Fundamental tutorial. Now, we're at chapter 3 of 6. We're going to be talking about Internet of Things now. And again, I want you to follow along. I'd ask you in the beginning to download the course outline and follow along so I wouldn't have to waste time going through what we're going to be covering so you can follow along. Now let's take a look on the Internet of Things, and we'll be talking about them in detail. So describing and examining the Internet of Things, we'll talk about IoT Hub, IoT Central, IoT Sphere, and we build on all the solutions as we go along. Now, describing and examining Azure Snaps is another thing that we'll cover. We do the Hadoop Insight and the Azure Databricks, so we'll look at those analytical services. We'll also talk about machine learning, cognitive services, and bot services. Then we'll move on to serverless computing and Azure Functions and a Logic app. We talk about it briefly. We'll talk about it in more details. Then we go into DevOps, talk about it, talk about GitHub, GitHub Actions, and Dev Test Labs, and then we'll be finished with that part. So you see, it's not a lot. Now let's talk about the IoT basics. Now, Azure Internet of Things, or IoT, is a managed cloud service that currently connects, monitors, and controls billions of IoT resources or devices worldwide. IoT is a connection of any electronic device or endpoint to Azure over the internet remotely. So it's the word Internet of Things, we get a good understanding. So we're connecting things over the internet through into Azure, and Azure is like a central controlling point for those resources. Now, at the most basic level, an IoT device has a circuit board and sensors. So sensors can measure things like sound, light, height, speed, smoke, anything that you could possibly measure, ultra sonic, temperature, motion, tilt, gases, accelerometer, flow, air pressure, alcohol, you could do a breathalyzer, and so much more. So anything that you could measure, you could use as an IoT device. Now, Azure IoT Hub, it's the most basic of the IoT services. It's a central messaging hub that's bi-directional communication between IoT appliances. So low-level devices like your refrigerator in your home, your washing machine, non-critical devices that you just need to get maintenance information on. Azure IoT Hub can deliver reliable and secure communication to those devices with telemetry and monitoring, file sharing, and request response method to control your devices. It can also route messages to other Azure resources. You can use IoT Hub to fully control your device remotely in the hub. So that is IoT Hub. It's at the bottom of the pyramid. Now, IoT Central has everything that IoT Hub has, but it has a little more control. It has a graphical user interface or more intuitive user face that you can use to do the same thing to connect, monitor, and manage your IoT devices. The physical dashboard can also aggregate surveillance over all your devices and alert notifications. So things like your smoke detector, your cameras with your sensor, your infrared sensors, your motion sensors, these are more critical or more elevated control. You could use IoT Central and you get a graphical user interface. Now, IoT Central allows you to fully manage the device, and it is a lot quicker to set up and use with plenty support than you would for IoT Central. Now let's look at the IoT Spare. It is the most comprehensive of the IoT solutions, and I'm sorry, you'd use it for more critical support, such as an ATM machine where security is paramount, but it is a little more in depth to use Azure Spare. It's not as easy as it is for IoT Central and IoT Hub, and we'll look at that. It comes with three parts. So there's a microcontroller unit that you would have to have installed in each device that you want to control with the Spare, so you could get end-to-end communication. There's also a Linux operating system that is common in electronic devices, consumer devices, and you also get the Azure Sphere Security Service as well. So there are three requirements that you have to have for the Azure Sphere to work. So the security, it uses the AS3 security, and it uses certificate-based authentication. The thing is, if you have an ATM machine, you want to make sure that when you're communicating with it, since it's so critical, it's not tampered with, and the device is who it said it is each time you communicate with it. So that's why the IoT Sphere have to have the specialized controller units installed in it. Now, for your analytics service, you use a IoT Edge. It's a fully managed data analysis model that you could use to push directly to your devices, which allow them to react quickly to state changes and needing consultancy in the cloud. So, in general, you want to understand IoT devices can use in almost any industry, doing a lot of different things. You could use it in agriculture. You could measure the temperature of your field. You could measure the soil. There's a lot of different things. You could measure the direction of the wind. You could use it on an aircraft to measure wind speed, temperature, height, altitude. There's a lot of different ways. If you use it in a home, you could use it to measure your smoke sensor. You could use it for your cameras, for your motion, for infrared. So again, you can anything that can be measured can be used as an IoT device. So I want you to get an understanding of that. Now, the next IoT basic that I'm going to look at was not on the course outline, but I saw this on the exam, which is IoT for Windows. I want you to understand that. I want you to read up on it. And I want you to understand that anything with a screen can be used as an IoT device using Windows 10 Enterprise. So if you're an OEM developer and you're building new devices and you're using Windows, you could use Windows 10 to Enterprise to control those IoT devices as well. I want you to read up on this on your own. Again, I saw it on the exam, but it's not on the course outline. Now let's take a look at some analytics services. We want to talk about Azure Synapse Analytics. It's the first thing Microsoft is posturing, so I'm assuming it's the one they want you to use or focus on. So Azure Synapse, it's more of the best of SQL Server enterprise data warehousing technology. It uses Spark for big data technology, Data Explorer, so it's able to interface with all the big data warehousing and data analytics services pipeline. So you're able to integrate it and get ETL and ELT services. You got deep integration, so that's Azure Synapse. You could use it. Now it provides infinite analytics service that merge data integration, enterprising, and big data analytics under single umbrella. So you're getting into continuous integration with that and continuous delivery as well. This is a brief overview of the Azure Synapse, and it has limitless analytic services that bind together. Again, it sounds like the solution that Microsoft wants to posture. Now let's look at another service. If you're using Hadoop Insight already and you're familiar with this open source product, then when you get into Azure, again, you're at home. You could use it as well. It's enterprise grade analytics service. You could use it. It's available in Azure, and there it is. It's Hadoop Insight. Now, again, it's compatible with Hadoop, Spark, Hive, LLP, Kafka, Storm, R, and a lot more. So it's very popular and it's well supported as well. Now let's take a look at Databrick. It's another solution. Databrick, it's an Apache Spark analytics services that integrates with data services in Azure as well. You need to understand what Databrick is used for. It's an analytics service. So we have Snaps, we have Hadoop, and we have Databricks. You need to understand Databricks and data science engineering provides interactive, collaborative platform. It's really a powerful one as well, and you could use it as well as an analytics solution. Now let's take a look at machine learning. And there's your overview of machine learning. You get an understanding of what it is. Primary goal of an AI solution is to adapt implicitly without being explicitly coded to do things. So you want AI that could adapt to changing environment and adapt on its own. So there are two unit models, machine learning, which requires a lot more skills and a lot more engineering work to actually get it to work. And then we also have deep learning, which simulates the neurals of the human mind. That is easier to implement based on the way it's implemented, and we'll be talking about that very shortly. There is a cognitive service that allegedly mimics the neurals of the human brain. So we want to take a look at that. So it's a lot easier to implement because you're implement them as REST APIs or using SDK libraries. So they're easy plugins. They're easier to use, much easier to use than machine learning, but you understand the difference between deep learning. So your text to speech solution and those types of things, it's easier to just plug them in and use them as an API in your solution. All right, so there's the services. The core thing I want you to remember from this is the five core pillars of cognitive services. What it's able to do, it's able to do recognition. It could take things like your driver's license and read information from it. It could recognize speech and text to speech. It could do language communication. It could hold a conversation between you and the machine going back and forth. It can make decisions based on knowledge, and you're able to apply search and learning to web sites with it as well. So you want to understand the pillars of the cognitive services, which is a deep learning, and you want to understand that it's easier to implement than machine learning that requires specific skill set. Now we're going to talk about bot services. This is probably the least explained services in the Azure ecosystem. Understand bots provide an experience that feels very personal, and it's highly intuitive and can respond intelligently to a lot of services. So when you call your bank and they want to see where to route your call, they'll ask you a series of questions before they transfer your call. That's a bot service in action right there. They're great human intervention. You could use them for repetitive tasks, and they're easy to set up and easy to implement as well. Unlike cognitive and machine learning, bots are learned resources that can offload common repetitive tasks and not have to worry about manually handling those tasks. The bots can handle them accurately for you. If the bot is really good, you would need absolutely no human intervention. Now I'm going to be talking about serverless computing some more. We spoke about it. You should understand by now that this takes place at the platform at a service level, and the key serverless computing t- tools that we have is functions and logic app. So again, you want to understand the difference. You can automatically provision, scale, and manage the infrastructure requirement using code. Now, in understanding the definition of serverless computers, I mentioned this, you servers are still running in the background. It's just the fact that you, the tenant, or the customer won't have to provision those servers. They're done for you by the cloud service provider. Okay, but the approach allows developers to focus and be more productive because they don't have to worry about the underlying infrastructure. They could just focus on delivering coding and delivering solutions. Now, here are functions. These are very critical pillars in the Azure Serverless Computing Solution Framework. They're small chunks of code that are usually used to respond to routine events in Azure. What I'm going to be doing, I'm going to take a quick break just to go into Azure, and we're going to take a quick look at a function just to get an idea of how a function works, and then we'll get right back into the code and take a look at the code. So let's open up another browser. Um, I want to take you from scratch, and what we're going to do, we're going to type in Azure again, and it should take me back to the same website, but I just want to be familiar with getting into the portal, and we're going to be going to the Azure. We're going to talk about Microsoft Azure sign in. You want to make sure you close to your account and go to the portal. Okay, what we want to do, we want to work on function. I always encourage you to type in the word that you're looking for. So we want to create a function in Azure. I want to give you a better feel so you could understand how to create a resource in Azure or create a service in Azure. So we're going to create a really quick function. Now, one thing you must remember, you need a subscription. I mentioned that a couple of times. I'm going to be using this subscription. You also want to have a resource group. Remember, we spoke about resource group a couple of times. We didn't really create one, but I have several resource groups that I'm working with for this AZ-900 fundamental. So we're going to create it in the AZ-900 fundamentals group. That's a resource group you would have to create on your own. In the essence of time, I bypass that. Now we have to give our app a name. So we're going to say AZ900.900, and that should make the name unique. We're going to be using a code. We're going to select a runtime, and we're going to select .NET because that's what I'm familiar with. Now, the thing with function is you don't need a text editor. You could just type right, even though you have access to a text editor. If you're a developer or you're not a developer, you could write the code straight in your browser and it could still execute. So that's a really powerful concept. You don't need any special training, or you don't need any special text editor. You could just write the code and it will work. You also get a rich set of templates that you could also use to actually run these functions. As you can see, I'm talking and we're going through the different steps that you would need to create a function. So it's creating this function. It might takes a few seconds for the first time, so we'll just wait for it to run. As you can see, it start creating some of the services that we need already. It's still in progress. I'm going to keep the video up because I want you to understand the different processes and steps that it goes through while it's creating a resource for you. And it sometimes it takes a little while to provision based on traffic, and also if it's the first time you using the account, it will take a little while. Now you get to see screen saying that the resource is created, and if you want to go to the resource, yes, we want to go to the resource. I want you to see that. What I'm going to do, because you have a lot of templates available to you, I'm going to go to quick start, and we're going to use one of the quick start templates. We could use with a code editor, but I want to demonstrate it without the code editor. So we're going to go straight into a function without using a code editor. And then we're going to be using a function that we actually pull from the um, resource pool that's already available to us. So we're not going to be using a function, we're not going to be writing a function from scratch. So here's the resources. I'm going to just do an HTTP trigger, and I'm just going to say create, and you should see your code in the browser very shortly. And there it is. So I'm just going to click on code, and then I should be able to run my code, and you could see how an HTTP request can trigger a function. So this is a function written in C sharp. If you're familiar with C sharp, this is home to you. This is a static asynchronous function, and we're going to run this function and see how it operates. So let's do test and run. It's going to do a post. Again, it's a request from your web browser, and we're just going to change this from Azure, and we're going to say Azure AZ-900 Fundamentals, just to make it seems as if we're doing something. So we're changing the name. We're running that function. You can see it's connecting, and boom, there's the result. Hello, Azure AZ-900 Fundamentals. So it works. So I just want to demonstrate to you how simple and how easy it is to go into Azure, create a resource group, create a function, and use it with no experience whatsoever, or no text editor, or no IDE environment. So let's go back to our course and continue where we left off, so you get an understanding of function. We look at it in details, and again, you could use your own background in C sharp, Java, JavaScript, Python, or even PowerShell if you're familiar with writing PowerShell scripts, or CLI script in Linux, or in Mac OS, or in Android. You could bring your skill set and you could use it for functions. So that's functions in a nutshell. Okay, we talk about it being event driven, and we talk about it microservices when we talk about Azure Service Fabric and microservices, and how we are able to write small snippet of codes that are able to do single task and do it really quickly and really rapidly. So this is a really powerful function in solution in Azure Functions. I want you to remember them. You'll see a lot of different questions about functions on your exam. They're serverless, they're event driven, they're easy to create. You could use your own skill set, any programming language, and they are able to do microservices. I want you to understand that. All right, so let's move on and take a look at logic apps. These are the benefits from functions. You could look at them at your leisure. I don't want to go through each of them, but those are the benefits. I provided them for you. Now let's look at logic apps. These are like functions, but they're created to solve more complex problem. So these are created for continuous integration, continuous automation, that types of thing for workflows. So it's a more complex solution than simple task that you're working with Azure Logic. But it's really powerful, and there's also a lot of support for Azure Logics as well. The part I want you to focus on is Azure Logics is a little more than a service, but it's a complete platform that allows you to create, deploy, and manage mission critical automated workflows that integrate your app data services and systems across cloud types. It is a part of your CI, continuous integration, and continuous delivery in Azure. So I want you to understand that. Very powerful. Okay, let's move on to Azure DevOps. So we're going to take a look at the DevOps pipeline. Now, DevOps, before I get into it, I want to give you an idea where the concept came from. So, before, as developers, we write a program, we have a change to make. We'd have to go to a change management meeting, state our change, and sit around and give the code to the ops team who would deploy it. Now, if something goes wrong, we would say it's the op team's fault, and the op teams would say it's a developer's fault. So, there was endless finger pointing. So Microsoft came up with this clever idea to broaden the scope, remove the silos, and let everyone collaborate on the process. So as a developer now, we no longer need to give our application to the ops team. With DevOps, we can do the deployment ourselves. So that is the concept behind DevOps. It's to solve complex problem internally that used to exist in the development or the IT environment. So DevOps is a full-scale, fully unified solution created to solve technical isolation issues in software development life cycle. And the life cycle is from ideation to sunset, from you have the first idea about a software until you retire that software. So it fosters a better bond between developers, operation, business manager, and all other members in an organization. So that's a brief history of DevOps. Let's look at some of the things it could do. You can gather input from several teams for seamless collaboration and continuous integration, giving developers complete control over their entire software development life cycle. Now, DevOps fosters a more agile and collaborative environment in an organization. So it is really a game changer for developers and in organization in general. So again, I explain why it was created so you could understand that part of it. You could read it on your own. I want to go into the DevOps toolbox and see what you could do. So there are plenty of familiar tools for both developers and operation teams for various platforms. You might be using Eclipse in Java, Visual Studio to do your development, Team Foundation services in Microsoft, or Git to manage source code. There is support for every single product that I mentioned that you're familiar with that you could use. If you're building, you could build your applications with Cradle as well. We have Azure Boards. Azure Board provides software development teams with interactive and customizable tools they need to manage their software projects. So it provides a rich set of capabilities, including native support for Agile, Scrum, and Kanban processes. So if you're a developer, you're familiar with these processes, the Agile model, waterfall model, you're familiar with those. You get calendar views, configurable dashboard, and integrated reporting. These tools scale as your business grows, so they grow with you. That's the Azure board. The Azure pipeline, it can be do automatic build as a developer. You could test, you could deploy your application from the pipeline. All projects are available to others. It works with just about any language or project type. Now, the Azure pipeline combines continuous integration and continuous delivery to test, build your code, and ship it to any target. So you have a lot of control with DevOps and the different tools in your toolbox, the Azure pipeline. And again, you get continuous integration and continuous delivery to solve complex automation processes in Azure. Those are the two. Okay, you also get continuous testing. You're able to detect bugs a lot quicker and work through them a lot faster. So the quality of your product is also better at the end. We get Azure Test Plan. It's another tool as well. It improves your overall code quality by using manual and exploratory testing services for your apps. So you can deploy them with high confidence because you're able to track and detect bugs a lot easier. You have Azure Artifacts. It's just like test management for your CI and CD pipeline. Azure Artifacts enables developers to share and consume packages from different feeds. So if you're a developer, you're probably familiar with packages such as NuGets and the different packages that could seamlessly load your packages for you in the right place at the right time the first time. You get those cool features with Azure Artifacts as well, and it integrates seamlessly with all your favorite packages. There you go with NuGet. There's npm with Python, Maven, and Universal Package. So these are very cool features that you would like in the Azure Dev Toolbox. Azure Artifacts is built on a consumption basis and is free up until you consume 2 gigabytes of storage. So let's move on. Now, Azure Dev Test Lab. This is probably one of the coolest thing in the DevOps pipeline. The Test Lab is a service that enables developers to efficiently manage virtual machines and platforms. So it's on the platform as a service. You don't have to wait for approvals and budget to do your testing. Believe me, you're going to see this on the exam. You're going to see it on the test. I want you to be get familiar with Azure Dev Test Labs. You're able to spin up a lot of virtual machine and load your application to do your testing in Azure without waiting on approval. You got to remember the purpose and remember what it's for. Okay? Azure Dev Test Lab and Azure Resource Manager templates used for creating test lab with all the necessary tools and software needed for testing purposes. Okay, here's some of the different benefits. And again, you could look at those. I put them there for you. I collect them, gather them, organize them so you could focus on them. You will be on your exams. Now let's look at the Azure GitHub. It's a multi-part source code or version control management system. But GitHub is very popular and it does a lot more than just version control. It's actually a real full base management system and probably the best on the market. The Git is the actual decentralized repository that stores your source code, and the hub is the client facing host that coordinates version controls, collaboration, reporting, documentation. So you see, you're able to manage an entire project through the Azure GitHub. Okay, here are some of the features. So it's a lot more than just source control, and it works with a Kanban board. If you're familiar with the Kanban board for project management, it's really powerful. So you see, you're getting a lot of cool tools in Azure that you could use as a developer. Now let's look at the Azure GitHub Action. It's similar to the Azure pipeline that we just talked about. Again, continuous integration, continuous delivery workflow, tool designed specifically for automatic deployment and launching from inside GitHub. So really powerful features, and GitHub, again, as you could see, it's a lot more than just a version control tool. It actually mature into a lot of different services, including documentation, which is very powerful, and collaboration. Mhm. So you can build, test, publish, release, and deploy code systematically with the GitHub Actions. Again, those are some of the tools that it supports as well. It integrates really well with those. Again, I want you to pay attention to those. It's so powerful. You could see GitHub Action, how it's used 75 million jobs on a monthly basis with about 7,000 different actions. That's a lot of processing, and it actually demonstrate how powerful and how useful the tool is to a lot of developers. It uses a YAML file to deliver the CD, CI, and CD solutions from inside GitHub. Okay, so this is the Azure PowerShell tools. So PowerShell, remember we spoke about you could use PowerShell and the client side scripting to actually deploy your operating systems. What I'm going to do, I'm going to take a quick look at writing a really small PowerShell or CLI code, and you could see it in action. We're going to create a resource group with that code so you get another hands-on experience in Azure. So let's look at the different things that we get. Okay, the Azure mobile app is a good compromise to perform one-off management administrative reporting action. So if you're on the go, you're on a long lunch break, you're able to use mobile app to do a lot of the services that you could do if you're inside Azure. We talk about the ARMS template in JSON where an entire infrastructure as a code could be deployed. You understand that? We're going to be writing, like I said, the client-side script using Bash shell feature in the from inside Azure, and we're going to look at a PowerShell script as well in Azure, so you get a feel as to how you could use it right from the command shell in Azure, which we worked on before, and you should have a good understanding of. All right, so let's switch over to Azure and take a look at that. Okay, so let's just go to a resource group. We're going to create a CLI just to create a basic resource group and demonstrate how easy it is to create a resource group using the command line interface in Azure. So we're just going to go to Azure. Remember that the command shell, the cloud shell is right here. You just want to click on it. It's connecting. We're waiting for the prompt. It's a prompt similar to the prompt that you would get in Windows. So it's connecting. We're just waiting on it. And there's the prompt. Alright, so we're gonna click on this. We'll make sure we're using the bash. Alright, I'm gonna do paste and I'm just gonna create it. I just want to change something to demonstrate. So it's AZ group create and the name, and we're just gonna give it a name. I'm just gonna call it AZ-900 resource group name, and we're gonna change the location. Okay, I made that mistake all the time. All right, just learn from my mistake. You want to position the cursor before you start typing, and we're just gonna call the name AZ-900. Just add that to it. AZ-900 demo resource group, and instead of West US, we're gonna say East US. And again, made the same mistake, but I'll just leave it. Learning curve. And we need to be here to change the location to East US. Again, I'm typing and I'm not looking at the screen, and that should be good for changing. So remember, we're looking for the Azure 900 East demo resource group. Okay, so let's run the script and see what happened. Okay, it said it's completed. So what we're gonna do, we're gonna refresh and we're gonna look for our resource group. Okay, and I'm able to refresh, and here's our resource group, AZ-900 demo resource group, and it's created in East US for us. So you see how easy it is to use the Azure the Cloud Shell and the command line script to actually create a resource in Azure. So we created our resource group. So let's get back to the course outline and then we'll take it from there. All right, so let's see what else we have on the plate. All right, so let's talk about Azure Advisor. It's used for cost reduction recommendation. So these features I'm going to be looking at real quick. You need to understand what they're used for. So first we're looking at the Azure Advisor, and it's used for cost reduction recommendation around reliability, security, and performance. So it's a part of the overall operation excellence in Azure. So you want to remember that. So these are the recommendations that are available. It's in 5 different groups. You could look at them: reliability, security, performance, so you have an idea what you could use the Azure Advisor for. Now let's look at the Azure Service Cells. It's a rare but necessary update. It gives you information about updates on outages and situations like those. It takes care of your overall Azure health. You need to also understand what the Azure health is used for in Azure as well. And I put together the details so you could read them and understand them as well for the exam. Now we want to take a look at the Azure Security Center. It's really a big part of the Azure ecosystem. Security is a really big part of Azure, and we want to understand it. It's a one-stop monitoring service with clear visibility, again, clear visibility of your security posture across all your services and infrastructure. So when we talk about cybersecurity and controls and policies, we want to talk about the Azure Security Center as well. Again, I put together a list of the different things that it's able to do so you could understand the power behind the Security Center. Then I'll be looking at some different details around Security Center. Policy compliance, it's a part of the Security Center strategy as well. It's also a part of your compliance. If you want to enforce your compliance, you understand EPA form. If you're in the United States, it's a protection for patient records. Now if that's a policy that you want to enforce, you could use a policy compliance to enforce it. It also give you like telemetry services and graphical things that you could look at to tell you what is in compliance and what is not, so you could look at it. Now we want to look at, I think I skipped past something there. It happens very fast, but yes, we did. Now, resource hygiene. It measures the security well-being of your resources, and remedies are categorized as high, medium, low, and it gives you a graphic display so you can understand what is high priority. So there's the red, here's your orange, and here's your blue, and it gives you a graphical overview. It even categorizes the different health monitoring and tells you what needs to be attended to as it relates to security. So remember the resource hygiene and what the resource hygiene is used for. Now let's go to your secure score. It's a single percentage value that also measures the organization overall security posture. So secure score incorporates security controls and recommendation as a percentage. So this is a recommendation of steps that you could take, and these are the different things that it provide for you. Again, you want to read through these and you want to understand them for the exam. But secure score, that's another feature in Azure. Now, Azure Sentinel is Microsoft cloud-based security and event management system, SIEM. So SIM aggregates data from many sources as a large scale and log it in a special format that can be used to detect threats. So again, you want to remember what the Azure Sentinel, the key feature of the Sentinel and what it's used for, and I outline it for you again so you could pay attention to them and go through them and get an understanding of what the Azure Sentinels um, capitalize on the different benefits that it capitalizes on that you could use. Now, the Azure Key Vault is a central cloud service for storing top secrets, your passwords, your encryptions, your keys, your certificates, your public certificates. That's what you want to store with your Azure Key Vault. Really powerful part of your security API keys. So your software would go through and get their password and their authentication through it. You get your SSL and TLS certificates as well. You get encryption. It's a really powerful tool and you want to understand it. Now, the last one says store secret backed by hardware security module, HSM. Now, this is actually a physical piece of security hardware that you could use, but it stores information in random access memory. It loses power, it loses all the information as well. And that's a part of your FIPS 140-2 Level 2 Validation, HMS. We'll talk about the FIPS 142 again, but you want to remember what you could use for that. Then you have the Azure Dedicated Host. We talk about dedicated servers when we do the evolution of computers, and I said we passed that, and I said not so fast. I'm not sure if you remember. Well, this is the reason why I said not so fast because we still have dedicated servers for special situations in Azure. Very expensive, it's not very common, but there are situations where a tenant needs to be the only person on the actual device that they're using. So they're used dedicated hosts, but you still could get those services through Azure. Now we're going to take a look at defense in depth. It's really a multifaceted defensive mechanism that designed to slow the advance of an attack, slow the penetration, and give security teams and system time to respond to potential threat. Now, as you could see, I drew an arrow going through from the physical security through identity, through the perimeter, network, compute, application, all the way to the nucleus of the information you're trying to preserve, which is your data. So I give you an idea of the penetration and how it would work. Now let's take a look at the different pieces that makes up the security in depth. There you have it, physical security. That's the surveillance. We talk about that, your biometrics and whatever you do to get into the building. And we talk about identity, which is your username and password. That's that level. Then we talk about the perimeter layer, where you talk about your distributed denial of service. We'll talk about that in more details. Your network layer. You want to limit resources using your firewall. Then we talk about your compute layer. Again, you want to use access to your virtual machine using Active Directory to control your user access. Then we talk about the application layer. You want to get your keys and your password through the key vault that secure your secrets. So we're building on the premise, the same premise about security here. We're hardening your security. Then we get to the data layer, where even the data itself, if everything they penetrate and get to your data, you want to make sure the data is encrypted and it's secured at rest and during transit. Now I created this little acronym to remember the entire defense in depth strategy, where you could go through all 7 layers. So I call it PIP and CAD. So the PIP and CAD is an acronym for all the different layers. You could use it for your perusal. Now let's move on. We talk about security posture. It has to do with how well you can detect and respond to a threat. Detection and actually respond. So you want to mitigate risk. Now we look at the common principle used to define security posture, and it's referred to as CIA: confidentiality, integrity, and availability. So confidentiality is actually need-based access. So you're only giving access to something only if you need it. If you don't work in accounting, you should not be on the accounting network or the accounting system. So that is an example of confidentiality. Integrity uses unique method such as one-way hashing algorithm to ensure that data is not tampered with during transit. Remember, you want to encrypt your data at rest and during transit for security. availability, this ensures that only users with the right credentials are able to access data, and this is also thwart distributed denial of services attack as well. So when we talk about role-based access control and who should have access to what, that's what availability is, what the system, who the system is available to. Now, firewall, we talk about it at the network level. It controls outgoing and ingoing traffic using rules that either relies on your IP address, internal or external, or a network protocol, TCP/IP, for example, or you would use port rules to shield the destination server. So you'll open or close a port. You could use a series of IP addresses to get through to your network. Now, the firewall services protects virtual network, your own private network, and virtual machines inside the cloud. So you get an understanding of how firewall works. It's a stateful device or a stateful service. It analyzes your entire network context across subscriptions and VNet from one central location. You can create, enforce log activities using static IP addresses. So you get an idea. This is your spoke VNet. This is one spoke, one network, second spoke. This is your firewall. This is your central network, and this is your layer 7 internet traffic coming in. They not decide what to block and what to let through as it relates to traffic, and it covers even your on-premises data center as well. So that's your firewall in a nutshell. So you're getting an idea of how the entire defense in depth layer works. Now let's look at the application gateway, which is a load balancer, and it's also a firewall, a web application firewall at layer 7 at the browser level, at the HTTP level. You get that type of protection as well. So it's a different type of firewall. Now, Azure Front Door and Azure Content Delivery Network also provides um, web access firewall as well services. So be reminded that there is a web access firewall using three other solutions in Azure. So there you got it. You're looking at front door and you're looking at the content delivery. You're looking at the actual domain name. This is your application gateway layer 7 web access firewall. It can use to route traffic. You could route your images. It's a load balancer as well. You could load your videos and you decide where they go. So that's a load balancer. So you have a firewall, which is a load balancer as well at the layer 7, and you also have it at the network layer. Now we talk about denial of service. Before, this is your denial of service protection. What it is really, it prevents fake traffic from inundating your resources with false information, and it pretend that if your system is busy when it's really fake traffic. So you see how your DDoS system is able to block and filter out fake traffic, and a real user and customer, their services will not be denied because you have the distributed denial of service attack, and then you could continue your business. So the whole idea is to prevent unwanted IP address from inundating your system with fake traffic, malicious traffic. And that's what it does. It filters those type of services out. Now, these services are offered in the basic and also standard. So you get it by default in your basic, but to get the volume to prevent volumetric attacks and other things like that, you need extra mitigation. You'd have to have this as a standard service. So remember that basic DDoS is on by default, but the standard you might have to pay for it. Not might, you will have to pay for it. So you want to understand the difference between those two. Okay. That's the difference between the two types of attack. I want you to read up on those as well. That's extra information that I'm providing for your perusal. Now we're going to be talking about network service group. So we're moving down the security posture ladder. So the network service group is like an internal firewall behind your public firewall. So it's a pillar, it's a critical pillar in the defense in depth security at the network level. And again, it's saying that it's like a firewall, an internal firewall, but the NSG is what you use to connect your resources together internally, your virtual machine. It comes with a set of default basic security rules. You cannot remove those rules, but you could upstage them with better rules with higher priority numbers, and I'll explain that within a second. There's it's telling you it's like your internal firewall. So by default, you get these rules: one, two, three rules. It will allow VNet inbound, so it allow inbound traffic. Allow Azure Load Balancer inbound. It will do that as well, and it will deny all inbound traffic. So depending on the rule number that's on, it will do exactly that. But you could upstage them using your own rules or creating your own rules. So by default, all inbound traffic is blocked. So by default, number three is on. It will deny all inbound traffics. So that's a default rule you'll get when you create a network service group. Now here's a look at the properties that you would have to create a network security group. It would have to have a unique name, and it would have to have a priority range between 100 and 4096. So if you want to set a higher priority than the priorities that were set by default, you just need to use a higher priority number and it will override that lower priority setting or rule. Now you need a source or destination IP address or a series of IP address that you want the rule to be applied to. You also need a protocol, TCP, UDP, or any other protocol. You need a direction, whether it's inbound or outbound, and you need a port or a range of ports that you want to open or close. You also want an action if you want to allow or deny access based on that rule. So that's an example and an idea of how NSG is set up. Now we're going to look at chapter 5, and we're going to look at another piece of the security puzzle. We're going to be looking at identity. We're going to be talking about governance, privacy, and compliance features. These are very short chapters, and we should be able to wrap it up real quickly. Okay, again, my name is Everett Morris from NetMerge, and I'm your instructor for the Azure AZ Fundamental tutorial. We are on chapter 5 of 6. We'll be describing identity, governance, compliance, and security in this chapter, and it should be a pretty quick chapter. It's not a lot to cover in this chapter, so let's get started. And now let's start with identity. Identity has to do with your password and username and your login credentials. So let's take a look. The idea behind access involves authentication and authorization. It covers the second layer in the defense in depth strategy that talks about identity. Now, authentication ensures the user service or device is well known and have provided required credential to legitimize access to a particular resource. So that is authentication. Let's talk about authorization. Now, authorization is when we talk about the role based access control before, authorization has to do with that, the amount of access you would have to a particular resource. So it builds on the authenticity of the party or the resource or the device that was connected, and then decide how much leverage is needed based on their role. Do you own the resource or only have read-only access to the particular resource? That is an example of the type of access that you might have. Now, this is authentication in action. We're used to it. This is a username, this is a password, and then authorization. We determine what do you have access access to, and what level of access would you have to the particular resource. Now let's move on. Active Directory. This is similar to the Active Directory that you would use on premises in Windows, and it fulfills the identity posture in the security in-depth strategy. Now, what we have is this is an on-premises and this is a Azure service. You could use Active Directory to cover both in a situation in a securing your so Active Directory is what you would actually use to fulfill the identity security posture. You could actually set passwords, you could actually set requirements for those passwords, you could actually manage those passwords. So you could use Active Directory to do a lot of things in Azure. Now, Active Directory also support what is known as single sign-on, another powerful feature in the identity model. So if you gain access to one resource and you already authenticated and authorized, you're able to access multiple resources as well once you're in Azure. It provides for clean management as well. So if a person, say for example, an employee should leave an establishment, you could just delete their identity information in one place instead of trying to locate all the different places that they would have access to and try to remove them independently or individually. Okay, so let's take a look now at Active Directory and how it helps apps management and device management as well. So authentication is not only identifies verifies identity. It can use to manage health procedures such as routine password resets, the password requirements. You could set standard, you could ban, and you could lock out users for specific reasons. If they attempt and fail a certain amount of time, you could do that. Now, single sign-on simplify access to multiple services and resources by reducing the need to provide your credentials many times for standard access. It also makes upkeep easy and more transparent, and I explain a few examples with that. Now, applications such as software as a service, your email can be managed and secured. Your Office 365, your Excel file, you could manage that with Active Directory as well. So you enjoy a better user experience, again, with single sign-on responsibility. Now, devices can also be registered and managed with tools such as Microsoft Intune. I spoke about that, and managed by Active Directory for you. This service in Active Directory can block access to unregistered devices. So even if you were able to be authenticated as a user and the device you're using was not authenticated, it could block service for you from that particular device. All right, let's talk about multi-factor authentication as we try to harden the security strategy or the security posture. So, multi-factor authentication is required. It requires the user to provide multiple source for authentication upfront and use those sources as secondary security point at sign-in interval. Something you know, something you have, or something you are, or something will be you are will be used to do the multi-factor authentication. So something you know is your password, your mother maiden name, something you have, your cell phone, your email, something you are. You're an employee, you're a contractor, those types of things will be able to use to help assist with multi-factor authentication. So you're being authenticated more than one different ways. Now we also want to look at conditional access. Either deny or grant user access based on identity signal from a user attempting to gain access. So you're using a new device, you're connected from a different country. All those things can be factored into conditional access, and this is done using machine learning or some other automated artificial intelligence sources. So you get a signal someone is trying to log on, the system would be try to make a decision whether to deny or grant access or enforce and ask for additional information. So that's a part of the conditional access. That's how it works, and it actually factors in into the overall security posture and I'm sorry, and security access in Azure. Now let's move on. Okay, let's talk about Azure governance now. This is an overall model of the Azure governance, and Azure governance is one of the pillars of Azure management, the process of maintaining your business inside Azure. From sunset to sundown, the entire process involves deployment, continuous operation, and then retirement. So, from the moment you have an idea, from ideation to sunset until you retire a particular service, we're going through the entire cycle. And there are pillars of management in Azure. So we want to look at these pillars um, independently. So we start with monitoring. So monitoring first collect, analyze data so you can audit performance, health, and availability. So we're looking at the overall governance. Configuration is the initial provisioning of resource. You thrive better on having automation to provide quality and efficacy while eliminating redundancies. Now, governance is the process and control appliance for all your resources. Your core planning and strategy must include Azure policy and Azure cost management. Now, security is managing the security of the asset, including prevention, detection, and reaction. The Azure Security Center is at the center of your security in Azure. So, all that is a part of the overall structure. Protection is making the data you secure highly available for business continuity with Azure Backup. Remember, we talk about disaster recovery and Azure Site Recovery. So, all those things actually contribute to the overall security posture. Migration is a lift and shift, frictionless lift and shift from on prem to the cloud. So, the Azure Recovery migrate virtual machine from both on-premises and other cloud service providers such as Amazon Web Services. Azure database migration, we spoke about the migration instance as well. Migrate database sources to Azure Data Platform. So we're taking a big look or a broad look at the overall governance in Azure. Now let's take a look at role-based access control. The term has come up quite a few times, and in my opinion, it should have been described further up in the course because we use it a couple of times and the user didn't get a good feel or understanding as to what role-based access control is. So let's talk about it. It allows you to use existing roles or predefined roles that is defined by Azure by default and simply assigning resources to those roles versus having to create your own role for every resources. So what it's doing is, remember when we talk about resource group, we could assign a role or a level of access to the entire group instead of going inside the group and assigning it to each of the resources in the group or the individuals inside the group. So it's really a structured way to manage resources using role-based access control. So we look at it from a role and a scope point of view. Now, the roles would be on the horizontal column, the vertical column. So you see the roles could be a reader, you could be an owner. So an admin would be the owner of a particular resource. It could be a virtual machine. It could be, a database. They're responsible for managing the database. And the different groups we have, you have the different tiers, which would be referred to as the scope. You could have a management group scope, a subscription scope, or a subscription, a resource group, or a resource itself. So that would be the scope. So you could assign roles to different scope in Azure to help simplify the process. So a scope or a resource set is a collection of resources having a role or role applied to them with predefined access right. A owner would be able, in this case, to create resource, delete resource, update resource. A reader would only be allowed to read or observe the resource. They won't be able to update or change or delete the resource. Now let's look at a few scopes and then we move on. A management group is a collection of multiple subscription. We familiar with that. A single subscription. We have a resource group, and we also have the actual resource itself that you could manage using role-based access control. Now, resource locks are designed to prevent accidental deletion of a resource. Say, for example, you have a virtual machine with your payroll information on it. You don't want that resource to be deleted. It's a collection of all your employees. It's a record keeping for your employees. So you could put a resource lock on that resource so that you won't be able to delete the resource. Now, a resource lock is an extra layer of protection that complements the Azure role-based access control policy that you already have in place. So it's really an extra level of protection. This is an overview of what a resource lock would look like, and then we want to talk about the different types of locks that you could put on a resource. Cannot delete. You're only authorized to modify and use a resource, but you cannot delete it without first removing the lock. In a good example of the role-based access control, you might only want an administrator to have access to remove that you cannot delete. You read only for everyone else except administrators. So read only is as is. You can read, but nothing else. Azure Blueprint. This is an elevated level of control. It is a much harder security lock that can prevent even an authorized person from removing a lock on a critical resource. So, for example, the HR computer that I spoke about that would have the employees' records on it, you don't want to delete it, you could use Azure Blueprint, where even in a situation where an administrator removed a lock that is on that computer, you could have Azure Blueprint automatically reassign that lock. So even though it has cannot delete except if you removing the lock from the actual resource, you want to use Azure Blueprint if you want to prevent that lock. So it's an extra layer of security. Now, resource tags is more a granular way to organize resources in Azure than using the resource group or the management group. So it uses metadata about a resource to provide more details about the resource. So it is a complement your subscription, a resource group, and management group pooling alike. So you're able to do more granular organizing with tags. I'll give you an example. Let's say you're tracking a project for a client, so you want to know all the resources that you're using for that particular client. But there are some resources that you're actually using for two clients, so they're serving two clients. So you actually want to get a granular understanding of what the cost is, so you could split it between the two clients. You could create a tag called duplex that you could assign to those resources. So although you're tracking the project independently on those particular resources, you could put a granular tag on it, so you could get like a detail level, costing on the different resources. So that's a good example of using tags. There's other situation where you can use tags, but you could use it for any form of organization that you see fit. You could also let the tags be assigned automatically to certain resources once they're created using policies. We'll get into that as well. So resource management is one way tags can help link across various groups. So I'm giving you some examples as to how you could use tags or incorporate them. You can use tags to ID most critical resources for mission critical or redundancy and SLA. You might have some resources that you want to use and do cross-pair replication for. You might identify those using resource tags. So there's a lot of different ways you could create resource tags and use resource tags as well. And I want you to read up on it. There's different ways you could create and modify resource tag through Azure using PowerShell, using the CLI, using a harm template, REST API. There's a plethora of ways that you could use to do that. So that's resource tag. Now let's look at Azure policy. Microsoft is very big on security, and a lot of it's been thrown at you really fast. I want to build on the overall security posture so you get an understanding of the security in depth. So we talk about the NSG as an internal firewall for your VNet for routing traffic. We talk about an Active Directory for controlling your identities, your password, and your users, and also your device management. We talk about role-based access where you control control the scope and role of each devices or users or application. We spoke about that as part of the security. We spoke about Azure policy as a broad governance strategy that you could incorporate with all your services. Now, they all have their very unique purposes in hardening and strengthening the Azure security posture. I want you to be able to understand how each of the different security categories actually factor into the overall Azure Security Center and the defense in depth strategy. Now, Azure policy enables you to create, assign, and manage policies that either control or audit your resources. Policy covers all of your resources, making sure rules and configuration standards are not compromised and are adhered to. So it's an enforcement. That's your Azure policy. You can use it at the individual group or the group level as an initiative. An Azure policy comes with built-in policy like most other resources. You can overwrite those policies. You could create your own policies as well. But you want to understand how policies fit into the overall picture. You want to understand initiative, definition, and how you could use policies in Azure. Now let's take a look at Azure Blueprint. I mentioned it briefly. Azure Blueprint is your enterprise governance and compliance solution. Azure Blueprint will manage the managers. So remember, the management group is at the top of your management hierarchy structure that you have. It's the highest level that you could set controls and enforcement. Azure Blueprint actually sits on top of that, and it gives you broad scope with far-reaching powers. Azure Blueprint will eliminate the need for micromanaging policies or compliances in repeatable situations. So you could use it broadly, and it has broad reach and scope. Azure Blueprint promotes the efficient orchestration in the deployment of templated resources and artifacts, and these are some examples in role assignment, policy assignment, Azure Resource Manager template, resource groups. You see, it stands on top of all of those services. Now let's move on. I'm going to talk about Cloud Adoption Framework, and it's actually a framework that you would follow if you want to adopt to the cloud, if you want to migrate into the cloud. So you want to move away from your off-premises solution and move into Azure. It's a proven five-step migration guide designed to help you successfully move into the cloud. So we're going to be talking about that as a synergy. Let's take a look at the framework and what's included in it. So the first step is you want to define your strategy. Why you want to move in the cloud? Is it for a cost saving? What is the greatest benefit or outcome that you're looking for from the cloud? So you want to define that strategy. You want to have a plan. Have your custodian or your excellence team ties goal to resources and action. Make sure you're able to identify your key workload, your core workload, and what actions you would need, what resources you would need in Azure to actually fulfill those goals. Or those actions within your plan. You want to ready your organization. You want to create a cloud landing zone, so to speak, with required resources using best practices and the right budget. You want to plan properly for your workload so that you don't have any failures or hiccup in your transition. You also want to adopt the cloud. You want to migrate and innovate at the same time. So while you're migrating, if there's any innovative means or efficacies that you could capitalize on, you want to do it at the same time. And finally, you want to govern and manage your cloud environment. You want to apply governance and strategy to your new environment and create measures and benchmark to advance operation and delivery. So if you follow these strategies, Azure is saying based on best principles and experience, you could have a successful lift and shift inside the crowd, a frictionless lift and shift, they say. Now, we're going to be looking at policy. We talk about the FIPS 142 before when we spoke about the HMS, which is the hardware security that use random access memory. We spoke about it. There's a lot of different compliance and policies. It's hard to remember all of them, but I want you to at least read up on a few of them on the Azure website, and I'll tell you where to get information on those shortly. But we want to look at some of the global compliance features that are there. We want to look at understand ISO 2000 2701 2013. For the US government, you want to understand the CGIS, the Criminal Justice Information System that is maintained by the FBI. If you want to use that system, you have to follow their compliance requirement. NIST, you want to understand the two NIST compliances. Now, when you talk about industry standard as it relates to the cloud or a particular industry, we spoke about the EPA form, which is to protect patients' record in the United States. You want to understand those compliances as well. FCA UK, you want to understand the different compliances so you can understand where they're applied and for what. There's also regional compliances, the Singapore MTC that governs your different levels, your infrastructure as a service, platform as a service, and software as a service. It governs all the different requirements that you would need if you provide those services as a cloud service provider, such as Azure. So you want to get yourself familiar with a few of these compliances and how they work. So let's take a quick look at just a few of them. It's impossible to go through all of them within the time that we are allotted. Now, the criminal justice system database is required to adhere. You have to adhere to the CGIS security policy, and that would be defined in a document that you could use. STAR certification is based on achieving International Organization of Standard, a international Electrotechnical Commission, and that's ISO and IEC 2701. That's one of the one that I pointed out. It looks at your cloud control matrix CCM, and this certification demonstrate that a cloud service provider is meeting some of the following requirements. Now, if you are an IPA insurance, I spoke about the IPA. I talk about the multi-tier Singapore. You want to try and understand that. It covers all different tiers. We mentioned it, software, platform, and infrastructure, all as a service. National Institute of Technology, the NIST. We spoke about that in cybersecurity as well. You want to understand at least a few of those. Now let's talk about trust and privacy. That's a big part of Microsoft. We're on to documentation now. Microsoft privacy statement discusses what data is collected from end user, why it is collected, and how it is used by Microsoft. The privacy statement covers all Microsoft services, websites, applications, software, servers, and devices. So it's a broad document. You need to understand it, and it's a trust and privacy. So it covers information gathered and how the information you use and why it is captured in the first place. Security Online Service Term, OST. It's a legally binding mutual agreement between Microsoft and their customers, between the tenants and Azure. This is mainly for online services, so software as a service, that type of thing. So it mostly covers Office 365 or your Microsoft Outlook email that you use. So it covers it at the software at the service level. So you want to remember that OST is affiliated with SaaS. Now let's take a look at compliance. The Data Protection Addendum (DPA) is a refined list of terms and their definition. So if you're looking for terminologies and what it means explained in technical terms, you want to draw for your Data Protection Addendum. So it covers data and security in online solution. The data protection addendum covers legal compliances as well, data processing procedures, self-disclosure, data security policies, data sharing, data retention, and data deletion. So it's really a deep um, document, deep rooted document that covers a lot of things. You can find the DPA on their licensing terms and documentation on the Azure Microsoft website. Now, the Trust Center, Microsoft is big in trust and integrity. It shows off Microsoft principles, what Microsoft is doing as it relates to integrity and trust. It displays security, privacy, compliance records that you could view and see what certification Microsoft is holding on to and what's the latest update, what their audit report. You get a good look at Microsoft. That is the Trust Center to see how trustworthy Microsoft is in doing self disclosures. Remember that the Trust Center provides support and resources for legal and the compliance community. So you could see if Microsoft is operating according to regulations. Remember the Trust Center. It also provides in-depth information about security, privacy, compliance, offering policies, features, and practices across Microsoft Cloud product. So the Trust Center is more like self-disclosure about Azure and Microsoft. This is the compliance offering. Now let's look at Azure Compliance Documentation. The Azure Compliance Documentation is a primary source library consisting of detailed documentation on legal, regulatory, and compliance matter about Azure. That's the compliance. There's more details about the compliance, how you can get up to date document and adapt during implementation, so you could get guideline on how to implement certain compliances of your own. So if you need compliance on APA, FIPS 142, etc., you could come to the compliance document. So this is one of the document that you could remember easily because the name, its namesake actually rings a bell. Compliance document. It allows you to follow the rules and procedure needed to meet a certain compliance. Now look, we're going to take a look now at Azure Government Region. We're going to look at Azure Government and its dedicated instance of Azure. Remember we talk about dedicated servers and it's still been in existence. Well, the US government actually use dedicated servers for their government services. They offer this is a service offered by Azure where you get physical isolation. So you're not sharing the cloud with other tenant. You're the only tenant. So the US government uses that at compliance level 5. It's the highest level. You have to get DoD approval to work with them. So you might heard someone saying they have to get clearance to work with the U.S. government as a contractor. That's the type of screening. They would do their own screening. So that's an example. Okay, these are some other examples of compliances that we're going through. You can get familiar with them. We can't go through all of them. You could read up these on your own and get an understanding of how compliances work. Now, Azure Sovereign Region in China, we spoke about that. It is administered through 21 via net. It's not done by Microsoft directly. This document explains why Microsoft couldn't do it on their own, and you could read through it and understand. The Chinese government requires the company to have 50% of their investment within the region in that demarcation zone. So that's a regulatory requirement that Microsoft is unable to meet on their own. So they provide the service through another company that could meet the Chinese requirement. Want you to understand that 21 via net, you will see it on the exam. I could promise you that. Now, as you migrate into the Azure cloud, there are two critical concerns that you need to address. You want to know how much the adaptation will cost you and what service guarantees you will have once you migrate. So we want to take a look at the factors that could impact that, and these are done as cost management and planning management. The second one is a service level agreement that we'll talk about in more detail. So we're on chapter 6, the final chapter. It's a very short chapter, so we're getting towards the end and we're doing pretty good. Now let's take a look at the total cost of ownership calculator. This is definitely going to be on the exam. The TCO calculator is called. It is designed to provide cost estimate. Remember when I spoke about economies of scale in the beginning? When we talk about capital expenditure and OPEX expenditure, and I said in the end I'll explain the ways how you could actually come up with those figures to make your assessment. Well, this is the calculator you need for that. The TCO calculator is designed to provide cost estimate that can be realized if an organization should adopt the Azure cloud instead of their on-premises data center. So it draws distinction between the two. Now, how exactly does it work? The calculators strive to capture your current on-prem capital expenditures in intricate detail. So you want to get, for example, your electricity bill, your lease, your rent, your server costs, your licensing. You want to capture every capital expenditures you possibly could capture so you could input them into the calculator. You also want to capture your workload. What are you doing? What type of database resource would you need? What kind of computing power you would need? So you'd have to sit down and get all those trivial costs, see it says CapEx costs, and apply it to a more definitive OPEX cost. So you want to do that, and the TCO calculator is what you would use to do that. Now the TCO is a three-step process, and this is how the process works. You have to define your workload as it is right now. You have to make your assumptions, and you have to adjust those assumptions as to what you would need as it relates to resources, and then you would have your reports that you could share with your manager or your excellence team or your higher ups to give them an overview of what you come up with for the transition. So remember your TCO calculator, it's a big part of your cloud adaptation process. Okay, and these are some other steps that you would follow with your TCO calculator. In the end, you should get a comparison of what it would cost you or what it is costing you at the moment in your data center. This example is saying triple sevens, 777,000 approximately, and if you should move in the cloud, this is saying 107,000. So you see the comparison. In addition to that, you want to do the comparison over a specific time period. This is done over a 2 year time period. Technically, Microsoft wants you to do it between use a 1 to 5 year time range or time period for measurement. So this is a 2 year comparison. You could do it for a single year, 2 year, 3 year, 4 years, or up to 5 years using the TCO calculator. So there's a good overview of the TCO calculator. You get an understanding. It's going to give you a comparison between your CapEx versus your OPEX expenditures. Now, let's look at some of the factors that could impact your performance in the cloud. There are many factors, and we want to take a look at them. Resource type, as unique costs and tiers assigned to them, and how you use them can actually change the dynamics of cost. There's usage meters that are assigned to some resources. You need to be aware of those as well when you merge into the cloud. You want to understand all the different cost factors. Location can also have an impact. Resources in some locations are more expensive than others. You need to understand that. You need to understand that the even deallocated virtual machines still incur costs for storage, but it's still a good idea. And while I'm on the subject, I want to bring this up as well. It will be on your exam. If you're forced with a situation where you're asked how you could cut costs on a virtual machine over a 3-day holiday or over the weekend or in a testing lab, you want to make sure you understand that you could deallocate the virtual machine and you're not paying for compute and CPU and memory time, and you would only be incurring storage charges. So you want to understand that while we're talking about ways to cut costs. Now let's move on. We want to talk about region tiers. We talk about that when we talk about billing zones, that they're logical grouping zones based on data transfer rates. The tier that you're using, if you're in zone 1, 2, 3, or 4, it makes a difference, and you need to understand how that can impact your costs as well. We're going to look at another type of calculator, which is called a pricing calculator. I want you not to make the same mistake I made with the two calculators. TCO is a total cost of ownership, and you're using it just when you're doing your cloud adaptation. The pricing calculator is what you would use on a routine basis, and it's used for estimate of cost running more trivial workloads over a specific period of time. So you would use it to calculate costs on a particular workload. So to use a PC that you would need a clean slate. For example, if you're going to use a computer, you want to understand how it works. So you would have two virtual machines. You want to make sure that they're virtual machine with nothing loaded on them or anything like that to get a good estimate. You want to use an application gateway in the apparatus, and you want an Azure database. So now you want these four resources. You want to look at them and see what it would cost if you should apply them to your a particular workload, so you could get a more trivial understanding of your basic costs. So let's look at this example. You use Azure Virtual Machine instances similar to virtual machine that you use in the data center. Now you want to use application gateway for your load balancing, and you also want an SQL database. Now you only need to add and configure the services to get an estimate. Then you can save, export, share the result, and you won't incur any costs for doing this estimate in Azure. Now, let's take a look at the Azure Cost Management. Now, the Azure Cost Management and Billing provides a free telemetry service that helps you monitor and manage your resources and billing. So again, it's helping you with costs. Another thing that helps you with costs is your Azure Advisor. It gives you cost recommendation, steps you could take to also save. So you want to understand that it provides a high level breakdown for you. We're talking about the cost management and billing now. So this is an overview. This is a graphical overview. It actually categorized the different costs that you're incurring at the moment. So you could see the different levels and the different costs, and you want to understand how those can impact your costs. We're still on cost management, so consider estimated costs thoroughly before you do your actual deployment. Make sure you need a resource and service before committing to it. Use your TCO calculator and your pricing calculator to help you understand metered billing and granular billing like micro billing. So you want to understand that. And again, here it is coming up now, your Azure Advisor. It will make recommendation to spot unused and underutilized resources, and it will help you to actually cut back and scale back on your resources as well. So you want to be able to, use that. Then again, with cost management, you want to consider estimated costs thoroughly. You want to look at the information you're getting from your advisor, and this is a general overview of the same information. It should say high, medium, and low. It's just saying high and medium. Oh, it is right here. There you go. You get the three different tiers. So you have two high impact resources that you could remedy, three a medium impact, and two low impact, and it gives you an overall saving that you would get from those projected figures. So again, this is all about cost management as you do your shift and lift, or your lift and shift into the cloud. Now, Azure Cost Management with free trial or credit-based Azure subscription, you can use your credit limit to actually control costs. So say for example, you developers in testing, you could set costs on the resources that they could use. You could set quotas and limit to actually contain your costs so you don't have budget overruns or a runaway budget that is on the loose. You can control those with quotas and limit. You could also use Azure reservation for discount. If you purchase your resources or you pay for them in advance, you could get up to 72% discount over pay as you go pricing. So you want to understand that as well. You also want to select low cost location that can also help you reduce billing. Again, but there's a drawback to that. You might select a low cost location and you don't get the throughput, the latency, and the performance you need, so you might have production issues. But again, it's an option. Now, Azure customers and subscription offers provide the greatest cost saving benefits as well. You want to look into those as well. So we're looking at different ways you could save money in Azure. Tags. You can also help you to identify and control costs on groups or resources pooled by providing real-time usage. So again, you could use tags to create a granular set of a granular pool of resources or tools that you want to track in Azure. Downsizing is also an option. If you're not using a virtual machine or a CPU, or you're not using the slated amount of resources, you cut it in half, you save 50%. That is what's going on here with this example. Now let's take a look at another cost saving measure. Deallocating and deleting resources is also an option. Remember, we talk about the virtual machines. If you're going away for the holiday or over the weekend, you want to deallocate those virtual machines so they're not spinning up disk and spinning running CPU and memory, and using resources that you're not using. Moving qualified resources and services from infrastructure as a service to platform as a service as a cost saving benefit. Also, if that's the case and you're able to do that, then by all means do it. OS licensing. This is also another great way. Software licensing is pretty expensive. If you're using an operating system such as Windows and Linux is cheaper, and your application or solution is not OS related, then you can change it to the less expensive operating system. Software assurance. This is another way of saving. It allows you to repurpose licenses if you have software assurance coverage for your license. So what that means, if you have a license on premises, you come in the cloud, you could use that same license and save on new licenses. Now we're going to talk about service level agreement, and we talk about 4.9, 5.9, and 6.9 throughout the course. Now, in principle, a service level agreement is a mere formal agreement between two parties, the client and the service provider, Azure and its tenant. In Azure, all product categories have an SLA listed online. All SLAs have three basic components. It has an introduction, general term, and an SLA detail body. Now, in Azure, an SLA is a promise to keep a service available at a certain percentage level. That's high availability. Remember when the first I introduced it, I spoke about your service being up 99.99% of the time or 100% of the time. That is your Azure SLA. That's what we are talking about now. Okay, this is an example of the SLA percentage. So two nines, it gives you an idea what downtime you could expect. So at two nines, 99%, you get 3.6 days per year in downtime. Three nines, you get 8.7 hours. You see how drastically it cuts just by having an extra nine. 99.95, still 3.9. It cut by an half again. You go to four nines, it goes to 52 minutes. So we're going from 3 days to 8 hours to 4 hours to 52 minutes. And then with five nines, we're already at 5 minutes downtime annually. That's an impeccable service. That's great service. And we still have 16.9 and 11.9 when we talk about composite SLA in region pairing earlier on in the course. So you get an understanding of what a service level agreement is. You need to understand it's an agreement between the customer or the tenant and Microsoft, and you don't need to know the intricate details about downtime, but you need to have an idea or an understanding at least what type of downtime you expect from 4.9s or 5.9s. I don't think you have to memorize the entire chart. You just need to have a general understanding. Now, if Azure failed to keep their promise, they will credit you. They won't refund you. They will credit you. And you have to request a credit within in a claim, and you have to do it within 30 days. So you want to understand that as well. You will be asked that on the test. You will be asked about getting refunds. No, you don't get a refund. You get a service credit, and you have to request the service credit, and you also have to request it within 30 days. So this is an understanding and a breakdown of what you would get if the service was down for less than 95%, you get 100% credit. If it's less than 99, you get 25% credit. And for your 4.9s, if it's below 99.99, you only get 10% credit. So that is the breakdown and the threshold for your SLAs and your credit request. Now let's look at an important question, Azure status, where you would get pertinent details about outages worldwide. It won't hurt you to check periodically, and what they're saying is to do your own investigation on about credit with Microsoft. This is a special order application. We're going to be talking about composite SLA when you're combining two SLAs and how it works. So we're going to look at the two scenarios that we put into the calculator before, the pricing calculator to get a trivial price. What happened is we put two virtual machine. So this is the formula. Two virtual machine is 3.9s and 3.9s. So that's your two virtual machine. This is for your SQL database. It's 4.9 and your load balancer is 4.9. So this is what your composite SLA would look like in Azure when you combine in multiple resources to get an understanding of your SLA. So you should be able to understand that. We're getting towards the end. Now this is composite SLA. Before you could actually request a credit, you have to understand when you combine resources together that it is going to reduce or increase your SLA. So you have to understand what a composite SLA is before you can make a claim for credit or before you could determine if you're due a credit in Azure. Now we're getting closer. This is a service level lifecycle overview. Each Azure service cycle starts in the development. It covers from ideation to sunset. We spoke about that. Information and requirements are done at this stage in the life cycle. So we're talking about different stages in a product life cycle. Now the public preview, you need to understand, it is not a software or an application or a resource that you want to put in production. Is just for testing purposes, and Microsoft is waiting on your feedback to finalize that particular product. So you don't want to use it in production. I put that in red. Now, general availability, we spoke about that before, and the three types of general availability. You want to make sure you understand them, and you want to understand that this is the actual product that you would put in production, and the only product that you would put in production is a product that is generally available, and the bugs are technically resolved for the most part, and it is ready for production use. Now use Azure Update to stay current and previews and check out cool products and updates from Microsoft. It will help you a lot. Now let's move on to the end, and that is what it is. We are at the end. Again, my name is Everald Morris from NetMerge, and I want to thank you for taking this tutorial with me. I hope you find it beneficial. And again, I'm asking you to like, comment, subscribe, and if you see it fit and want to help these free products and these free training, you could also donate using Cash App. Again, I want to thank you and have a great rest of your day.